Good morning, everybody, and welcome to our virtual dam owners workshop. Day one. We'll be starting in a few moments, so sit tight. We're just letting a few more people join. We're at 193 attendees right now, and we've had 375 people sign up, so should be a great day ahead of us.
Good morning, everybody. We're waiting for a few more people to join us before we begin. We'll give it a couple more minutes and then I will start. Okay, I'm going to go ahead and get started. Good morning, everybody, and thank you for joining us today. Welcome to Maryland's virtual dam owner workshop. Sorry about that. This is the first of 2 sessions hosted by the Maryland Department of the Environment Dam Safety Divisions. My name is Jennifer Smith, and I am the manager of the Sediment, Stormwater, and Dam Safety Program in the Water and Science Administration of the Maryland Department of the Environment. MDE and our Dam Safety Division staff are very excited to offer this workshop to our Maryland dam community. However, we are new to orchestrating a virtual workshop using Microsoft Teams. And yesterday we had a number of problems while we were practicing. As you all probably know, Microsoft Teams was down yesterday, so hopefully we will not run into that issue today and this will run smoothly. We have over 370 professionals registered for the workshop. I don't believe they're all here yet, but I'm going to go ahead and get started. You all represent the Maryland dam community, the owners and the operators, the designers, the engineers, the emergency managers, and we hope these workshops provide you with the opportunity to meet your fellow dam community members, although you're doing it virtually this year. There are some benefits to having a virtual workshop that we are able to have 370 people attend, which is that's the largest number that we've had sign up for one of these workshops since we've been doing them regularly over the last 5 years. Now, first, let me go over some important workshop housekeeping items. Just briefly, you are all on mute and your videos are turned off. You're not able to unmute yourselves. That's the way this Teams session is set up because there's too many people, obviously, to orchestrate having one person talk at one time. So you will be remaining muted, but please locate the question and answer function on the toolbar at the right top of your screen. You can use this to ask questions or make comments throughout the day. We're going to have about 30-minute sessions today, and there will be some time between each session for questions and comments. And then we will also have a 5-minute break between sessions. Unfortunately, we do not have a lunch break set up for today. We're going to try to get through this next 4 hours without a lunch break. So I guess you can eat at your desks. Today's agenda is divided into 7 topics. First, Hal Van Aller will talk about hiring a dam engineer. Then Visti Dalal will talk about the lessons learned from the FEMA High Hazard Potential Dam Grant Program. Then we'll hear from John Roach, and he'll be discussing the permitting process. Hira Sharitha will talk about dam ownership and enforcement issues. And dam safety issues at dams will be discussed by Kelly Flint. John Roach will then come again and talk about dam safety guidance documents. And then finally, Ray Barr will wrap it up with some closing remarks and any additional questions or answers that we have not addressed. So let me just briefly talk a little bit about what does Maryland's dam safety program look like today in 2021. There are currently 627 dams on Maryland's dam inventory, and there are an additional 15,000 or so small ponds in Maryland. And these are the ones that we know about. There are new, existing, or unknown dams that are added every day to our inventory. Over the past 12 months, we have added 18 dams to the dam inventory that were previously unknown to us. Maryland dams are spread out across the entire state. There is no county in Maryland that can claim that they do not have a dam within their jurisdictional boundary. The majority of dams in Maryland's dam inventory are low hazard structures, but there are about 250 dams in Maryland that if they failed, could cause significant property damage or kill somebody. And Maryland dams do fail. This slide is a list of all the dams that have failed or nearly failed in Maryland in the past 21 years. There have been 29 dam failures in Maryland in the past 21 years. That's about 1 per year. And not all have occurred due to hurricanes. There have been at least 45 dam failures or near failures in Maryland since the department began maintaining records on dams since the 1930s. And some of these incidents required the evacuation of downstream residents and property owners. Fortunately, there have been no loss of life, but many of these dam failures cause costly damage to public and private roads, public and private property, and the environment. Maryland's dam safety program works hard to ensure the safety of our dams and small ponds. And we do this by ensuring designs meet minimum standards, proper construction methods are followed, and our existing dams are maintained. We inspect existing dams and those under construction. FEMA requires Maryland to inspect our 102 high hazard dams once per year at a minimum, and our 148 significant hazard dams at a minimum one time every 3 years. This year, our inspectors got off to a slow start when in March, Governor Hogan shut down the state due to the coronavirus and ordered all Maryland state employees to work at home. These things started looking better in the early summer when our dam safety inspectors were able to get out to do some field work, albeit with many safety restrictions, such as wear a mask, stay 6 feet apart, wear gloves, and only one person per vehicle. We were able to get to 170 dams. And this allowed us to meet the annual inspection requirement for 71% of our high hazard dams. This is why your due diligence in performing regular inspections on your dams is critical. Maryland needs you because, as you can see, we struggle to meet our inspection goals. The same dam safety engineers performing those inspections are also reviewing dam safety permit applications, reviewing emergency action plans, providing outreach and training, and performing other critical duties. What else have we been working on? In addition to dam inspections, our dam safety engineers have been working very hard on some important changes to our dam safety program. In February, we created a new dam safety permits division headed by John Roach. This division will help focus on permit processing updates to ensure efficiency and clarify requirements. We created 11 technical policy memos to help clarify some existing criteria that is difficult to interpret. These are located on our website, and I think John Roach will talk more about these later today. We are working on a full dam safety regulation update. Maryland's dam safety regulations have not been updated fully since 1978. We also recently worked with the Maryland Emergency Management Administration, or MEMA, to update Maryland's hazard mitigation plan to incorporate a dam safety element. With the incorporation of this element, we were able to apply for and receive 2 new grants from FEMA and 1 from EPA. And with these grants, MDE will update Maryland's Atlas 14 design storm information. We'll be creating a specific Maryland-specific probable maximum precipitation design storm. We will be creating a GIS-based dam breach inundation mapping tool for all dams on Maryland's inventory, and this tool will help inform emergency responders, MEMA, and local jurisdictions. And finally, MDE received pass-through funds for a few dam repair projects through the High Hazard Potential Dam Grant Program. And Visti will talk more about this program later today. Now, as some of you already know, our review responsibilities in the Dam Safety Division have recently had to extend more and more to small pond reviews. Historically, dam safety focused attention on larger dams that present a significant or high hazard, with 378 small pond reviews left to local soil conservation districts. However, circumstances recently have required many of these 378 reviews to shift to MDE through the dam safety permit process. This has impacted the local development process, and as a department, we are working through these issues. We are working to propose regulatory changes. We also held 3 workshops in the fall of 2020 on small pond design, construction, and maintenance issues. We held a number of small pond coordination meetings and continue to hold these meetings with the local soil conservation districts to discuss small pond approvals and design criteria. And also, as a part of our regulation update, we recently published proposed regulation changes to the delegation authority for small pond approvals to allow MDE to designate an entity other than a soil conservation district to approve small ponds. We are also currently discussing thermal review issues with the Department of Natural Resources for small ponds located in natural trout watersheds. And we hope to get some written guidance for local review authorities and soil conservation districts on what is required for small ponds located in these cold water streams. So what are some of the hot issues facing Maryland's dam safety program in 2021? Well, many of the same issues that we faced in 2020. First and foremost, our infrastructure is aging. Maryland's dams are aging and deteriorating, while downstream populations are increasing. The majority of our dams are over 50 years old, with components that have reached the end of their life. Yet Maryland has no dedicated funding source to assist dam owners with repairs. Maryland now has 166 dams on our inventory that are considered in poor, very poor, unsafe, or unacceptable condition. And resource limitations don't stop at dam repair funding. MDE has recently dropped from 9 dam safety engineers to 6, and soon to be 5. We currently have 3 vacancies in our dam safety divisions, and these vacancies put a strain on our engineers by increasing the number of dams each is responsible for, and increasing permit review times as we have fewer reviewers to process applications. But hey, we are hiring. So if you are interested, check out our job announcement, but don't delay. The job announcement closes on March 19th. Finally, we know that our climate is changing. We are seeing more short duration, high intensity rainfall events. And what will this mean to the resiliency of our dams? What we do now to ensure our dams are in good condition will be critical to the challenge of addressing the impacts of climate change. Finally, let me touch on something that is becoming more of an issue for us as a program, especially as our dams age and deteriorate. And this is existing farm ponds or recreational ponds that go through an ownership transfer due to subdivision activity. This slide shows an example of one that recently came to our attention. The photo on the left is an aerial photo taken in 1993 of an existing property that was in an agricultural use. You can see 2 ponds on the property and the location of the dam of the lower pond highlighted in yellow. On the right is an aerial photo of the same location taken recently. This shows the residential lots, roads, and homes after a subdivision was approved. The 2 ponds and dams were transferred to the Homeowners Association for ownership and maintenance. But was the condition of the existing ponds evaluated before the subdivision or property transfer occurred? Well, MDE was recently notified that the dam was overtopping, this is the lower dam, was overtopping due to a significant rainfall. And after inspection, we determined that the dam is in an unsafe condition requiring immediate action. These recent photos show the condition of the lower pond and dam today. The earthen dam is believed to be about 70 years old. The photo on the left shows the pond and the location of a clogged control structure and the location of the dam where it was overtopping. The photo on the right shows significant erosion and slope failure on the downstream slope of the dam. And the photo on the bottom left shows the existing corrosion of the dam spillway pipe. Here's another recent example. In this case, there were 4 old ponds on a large parcel. One of these ponds was on Maryland's dam inventory. Now, recently, this large parcel was approved for a residential subdivision. Multiple single-family lots were created and sold, some that bisected the ponds and the low hazard dam. The property owners of the new lots had no idea they were now dam owners. In addition, forest conservation easements were recorded over these existing dams. These are pictures of the 4 existing ponds. You can see significant damage to the spillway structures for ponds 3 and 4, both of which have dense mature trees on the embankment. The dam for pond 3 is partially breached. The dam for pond 4 is severely eroded under the spillway. To repair both of these ponds, the embankments and spillway structures need to be completely rebuilt. Trees and woody vegetation exist on the downstream slope and toe of the embankment for pond 2. And the corrugated metal spillway pipe shows significant deterioration. For the inventory dam, debris is blocking the spillway, and several areas of seepage and erosion on the embankment are evident. These 7 new lot owners unknowingly purchased lots with these expensive existing problems. For those of you who are engineers providing design services for developers, please recognize that any existing dam or pond on the property must be maintained in good condition, even if it is not going to be used to manage new development stormwater runoff. Repairs to these existing structures should be required as part of the subdivision process. If you find one of these structures and you are concerned about notifying the existing property owner of the issues, contact MDE. We can assist with ensuring compliance. So that is all I have now. I'm going to, the most important issues and discussions will follow. I'm going to ask the moderator, are there any questions at this time?
Jennifer, we do not have any questions for you at this time. I would like to remind everybody to use the live event Q&A. It should be a question mark with a little chat box next to it. We have been getting some dialogue coming in. There is one question about receiving PDH credits for the workshop, and we responded back to them in the Q&A. We're going to provide a certificate of attendance to all attendees, but you will need to self-certify per DLLR rules. We're going to now, seeing that there are no more questions, Jennifer, unless you have anything more to say, we're going to take a 5-minute break and we'll be back with Hal Van Aller covering hiring a dam engineer. We will be back at 10:27.
Okay, well, good morning. I hope my mic is on here. Thank you, Jennifer, for a good introduction. I'm going to spend a few minutes on hiring an engineer. Good. Thank you, Charlie. As everybody knows, or most everybody, I've been with the dam safety program for almost 38 years now. And as Jennifer mentioned, dam owners are responsible and liable for operating their dams. Why is this not working right? And proper operation, maintenance, and repair are key elements in preventing failure and limiting liability. So in some of the examples that Jennifer mentioned, these new dam owners had no idea of the liability that they were inheriting when the developer subdivided their property and split up the dam and pond ownership among many people. So one important procedure for ensuring proper operation of a dam is procuring the services of a qualified engineer. The Association of State Dam Safety Officials, ASDO, has quite a few resources available for dam owners, one of which is this fact sheet on how to procure the services of a professional engineer. If you go to damowner.org, you will find a bunch of resources, not damowners.org, that takes you to a private website, but the singular damowner.org takes you to quite a few resources. There are some things that are not required to get a permit or an engineer, such as removing debris from a spillway, removing accumulated sediment from forebays and low flow openings in your spillways, replacement of construction joint sealants, maintaining existing tow drain systems or internal drain systems, or installing seepage measurement devices, operating and exercising drain gates if you're just going to open and close it to make sure it works, replacing riprap, erosion protection material on the upstream face of the dam up to 10 square yards, and filling in animal burrows. These are all things that we expect dam owners to do. There's more details that you can find on all of these activities, ordinary activities, in MDE Policy Memorandum number 11. So if you have a dam and you go out and inspect it and you find a big hole in it, like this one, you're probably going to need the help. You will need the help of an engineer to address the problem. This particular dam, it's brand new, and it failed when there was only a couple of feet of water in it. It's about a 30-foot high embankment that the pipe was installed in a trench cut through the foundation. You can kind of see some rocky material. Sorry, it's fuzzy. That's the best picture I had. It's about 25 years ago now, maybe 30. Here's another brand new dam, small pond. It was built and filled up right away, and right over top of the pipe, there's this big sinkhole. Here's a pipe from about 40 years ago, a photo that was taken of a dam with a concrete pipe. I'm not always going to talk about corrugated metal pipes, but corrugated metal pipes are a problem, but any kind of pipe can have a problem. This is one that was built on a soft foundation, and almost immediately after construction, the foundation settled and the joints opened up. This is a confined space. Kelly's going to talk a little bit about confined spaces later in her presentation, but you really can't go into a spillway like this and do what he's doing without special training and special equipment. Here's another dam. This one's in Maryland. It's about 15 feet high. It was a sediment control basin for a EPA RCRA site. And it was built, the embankment was constructed, and a notch was cut through it, and a corrugated metal pipe was installed. It failed immediately upon first filling. So the pipe, you might notice a theme here. The pipe is the problem with a lot of dams. It's the weak point. It's a discontinuity in the structure. What we like to see in a dam is fairly uniform fill, uniform slopes on the foundation, no abrupt changes, but you put a pipe into the embankment, that's a discontinuity, and it's just asking for differential settlements or cracks or other problems. If you inspect your pipe and you find some leakage, you're going to need help from an engineer. Here's one where the pipe, it's about a 48-inch diameter corrugated metal pipe installed in 1964 in Carroll County. And the soils in Carroll County and a lot of parts of the state are very corrosive and aggressive, and corrugated metal pipe only lasts about 25 to 30 years. So this is well beyond its expected design life. When we looked at this dam in 2010, you could see corrosion. And right here in the circled area, there is a little bit of orange color and deterioration. But when we looked at that pipe again in 2017, that circled area had completely failed, and there was about a 2-inch diameter hole where the reservoir was coming into the pipe. So people might think, well, okay, let's not have a pipe. Let's put a spillway on the embankment and let flows go over top of it, a reinforced concrete channel. How could that go wrong? Well, every one of these overflow spillways that I've seen on an embankment have failed in some way or another. Let me just check. I'm getting a lot of messages here. Should be okay. So the problems that do require an engineer. If the state has done an inspection and we've said that your dam is inadequate spillway, it could be a change in hazard classification called hazard creep. As Jennifer mentioned, maybe a subdivision has been built around and downstream of an existing pond. Well, so the pond now becomes a dam that might be something other than low hazard. So if you look in COMAR, the spillway criteria, spillway capacity requirements for a significant or high hazard dam is much larger than for a small pond. We might have determined that the emergency or auxiliary spillway is subject to erosion. There have been a bunch of failures of large NRCS type dams that had earth and emergency spillways that have failed when they were called into use during a large storm by erosion. In some cases, a 50-foot high dam with an emergency spillway failed all the way to the bottom of the dam and the entire reservoir was lost. It's a possibility that you could increase your spillway capacity by putting overtopping protection on a dam, but that's tricky, requires special design and an engineer that knows how to do it. Any changes to a control structure, including water quality retrofits, smart ponds, like CMAC devices, any changes either require a permit from MDE Dam Safety or approval of the Soil Conservation District. You'll need an engineer to evaluate and repair severe spillway deterioration. As I showed some of the corrugated metal pipes, you'll need an engineer to evaluate whether it can be repaired or slip lined. There's special considerations if you slip line a pipe. If there's erosion or slope failures at the embankments, sinkholes, seepage problems, any of these might require a tow drain or filter installation that requires design by an engineer. It's not just something you can go to Home Depot and get the materials and apply it yourself. And removal of large trees and dams. And finally, if you're evaluating the condition of a dam, you want to drill some borings in it, that can be a problem that can make that can be something that can make problems even worse if you don't know what you're doing or your driller doesn't know what they're doing. So you need a permit from Dam Safety to drill holes in your dam or near the dam. So I mentioned before there's some issues with slip lining. So I'll demonstrate that with a slide here. This is a cross section of a dam embankment with a standard riser on the left-hand side and the impoundment and a barrel going through the dam at the bottom. It's made of sections of pipe, and the downstream section I've shown there's an open joint, and then there's a black oval on the second section from the end, and that is represent a hole in the pipe, maybe due to corrosion. So if the pipe has been in place for a number of years and the pond has been impounded for long enough period of time to generate steady state seepage conditions, the water going through the dam may have found these openings, the crack or the hole in the pipe, so that the phreatic surface is maintained within the dam embankment, as shown here. But if you come along and put a slip liner inside the pipe and grout the space between the slip liner and the existing CMP, the seepage paths that previously existed are now going to be disrupted, and seepage is going to migrate to the downstream toe of the dam. And if that's not controlled with a filter and drain system called a filter diaphragm, then seepage along the outside of the pipe can occur. And if that's carrying soil, as in this case here, this is muddy water coming out, that means a hole in your dam is washing away and the soil is washing out, the hole's getting bigger, eventually the dam's going to fail. There's a case in Calvert County where the dam serves as a community roadway, and the engineers elected to replace the deteriorated pipe with a slip liner, not replace it, but to repair it in place, because they didn't want to disrupt the traffic on the road in the community. However, a few months after the slip lining project was completed, we got a call from the homeowners association that said every time it rains, the lake level increases and it never goes down, and there's no water coming out of the pipe. What's going on? So they had the engineer and a contractor come back, and they had to dig up the pipe because there was obviously a problem with it. No water was coming out. And this is at the downstream end. Corrugated metal pipe was excavated, and they split it open and found that when the contractor was pumping grout into the annular space between the old CMP and the new liner, they used too much grout and too much pressure and actually collapsed the brand new slip liner and filled the pipe up with concrete, basically, so that there was no way for water to get out. So they ended up digging up the road anyway to replace the pipe. This particular incident resulted in the recommendations in our guidance document for slip lining to make sure that somebody is watching the conduit from both ends, or at least that you can see through it while the grouting is going on, to make sure they can stop in time before the pipe is completely filled with grout. Concrete pipes could leak. This is a road culvert in Montgomery County that also serves as a pond. It was not designed to have watertight joints. And the contractor thought they could just come in and plug these holes with hydraulic cement, but that's only part of the solution, in that the seepage that's coming in these joints is going to have to go someplace, and it's going to go to the downstream end of the pipe. Lots of problems with pipes. Here is a dam that was constructed in Missouri. It was a pretty large, like 24-inch PVC pipe that the contractor installed as a temporary diversion pipe that they diverted the stream through while they built the embankment. And at the end of the project, the contractor and the owner decided that they liked having this PVC pipe through the embankment as a low flow opening. So they approached the state for permission to maintain it instead of grouting it closed like the construction documents required. And the state had just obtained this new conduit camera. And they said, well, let's try out our camera and take a look at it. Well, they got halfway through the pipe and found that the gasket in some of the joints was visible, and a little farther down the pipe had actually collapsed. So they ended up grouting it closed. But you need an engineer or somebody with experience with dams and conduits to make that assessment. In fact, one of our recommendations now is for any conduit put in a dam, whether it's an internal drain or the principal spillway, one of the last steps that the engineer needs to do before they certify that the project was completed in accordance with the plans and specifications is run a camera through those pipes to make sure they're okay. The sewer companies are required to do that when they put sewers in and water lines in. And we had never done that in the dam safety community until we started seeing problems. There's cases now where tow drains that were put in 30 years ago on state dams, we thought they were functioning fine. And then after 20 or so years, they stopped collecting all the seepage, run a camera up in them, and found out that the pipes had collapsed during construction 30 years ago. And we never knew it. So the Hira and John are going to talk a little bit about permit requirements for dam construction, alteration, and repair. And Maryland law requires that a permit is required for construction or alteration of a dam, any changes to a dam, unless the plans are approved by the Soil Conservation District. And as Jennifer mentioned, there is a change that would allow certain designated entities to do pond approvals, but we have not entered into any agreements with any entities yet to do that. A dam safety permit is required to drill borings in or near a dam. John's going to talk about a near failure of a dam in New York State. COMAR requires that one engineer, COMAR is the Code of Maryland Regulations, that one engineer, which we refer to as the engineer in charge, be responsible for an entire project from its design, that's from doing the original concept and borings, through its construction. The engineer must be a registered engineer, professional engineer, experienced in dam design and construction. So very few times will one engineer be experienced enough in all phases of construction, geotechnical, hydrology and hydraulics, and structural. So we usually see a design team involved in the project, but one engineer must be designated as the primary engineer in charge. And he should be reviewing all of this submittals to the state, the breach analyses, a hydraulic design, a structural design. It may be done by different people, but it should all come under his authority. The engineer in charge must submit an affidavit asserting that they're experienced in the field of dam design and attach resumes of all the other people that will be involved in the design and construction team. During construction, the engineer in charge must also submit periodic reports to MDE to ensure that the work is completed in accordance with the permit and the approved plans. So, how do you go about procuring the services of a qualified engineer? I've already mentioned why we need an engineer. So how do you choose somebody who's best for the particular project? There's not one engineer that is good at everything. So depending on what you're proposing to do, whether it's slip lining a pipe or putting in overtopping protection or completely removing the dam and starting over, you might have different engineers with different experience. One thing to keep in mind is the selection of the engineer should be based on qualifications, not on fees. The experience and knowledge of the engineer who's going to be doing the work is a determining factor in making the selection. The fee-based solution where you get just a cost estimate from different engineers is not recommended, because an engineer who doesn't really know what he's up against is going to have a lower fee than somebody who's more experienced and knows what's going to be required, but that person's probably going to have a higher fee. So you really need to put a little work into your effort in selecting an engineer so it'll save time and money in the future. Criteria to look for: registered professional engineer with 10 years of experience in dam design and construction, knowledge of Maryland laws, which are called rules, and regulations governing dam design and construction. So somebody out of state may give you a low bid, but if they don't know what Maryland's laws require and their state is different, you might get some submittals that are going to have to be redone and cost you time and money. And specific experience in areas of hydrology, hydraulic structures, soil, seismic design, seepage, geotechnical engineer, and what are the common deficiencies found in dams, different than roads and highways and bridges. Step 1, meet with potential consultants and get their proposals. At least 3 are recommended. Should include a detailed scope of work. Then you'll pick a contractor and start the design process. Finally, you're going to apply for permits, get all the bids, supervise the construction, and at the end provide construction documentation, all of the testing that was done, all the photographs taken, and as-built drawings. So a quick graphic that shows the time frame. We usually tell people it's about a 2-year process from submitting an application to getting a permit. The big unknown is the purple box. It says permitting there. It shows about 6 months on this particular graphic that I borrowed from Iowa Dam Safety presentation on how to hire an engineer. But there's lots of analyses, H&H and breach analysis, hazard classification, structural analyses. It can take much more than the 6 months shown here to get all the analyses done and to the point where we issue a permit. And then construction probably will take more than a few months. Depends on the scope of the project. So it's recommended that you get references and a portfolio of projects from your engineer and contact those owners and contractors to discuss the engineer's performance. Look at the projects that have been completed under his leadership. And keep in mind that an engineer that claims he's worked on a lot of Maryland 378 type stormwater ponds might not really qualify them for work on high hazard dams. They might be qualified, but somebody that's worked on dozens of small stormwater ponds does not necessarily translate into experience for high hazard dams. Discuss engineer selection with the dam safety program before you actually pick that engineer and get in and under contract with them. We can't recommend any particular engineer, but we can give them give you an assessment of their experience on previous projects. And if the engineer has come up with a recommended course of action, run that by us before you commit to that, because there may be some things that we're not going to approve. And go to ASDSO's website, and there's other websites, but go to the website about the basics of dam safety and be knowledgeable in regard to the laws and regulations which you need to comply, so you know if the engineer is going to satisfy those requirements. Other activities that might require an engineer: annual dam inspections. Certainly dam owners are expected to do inspections of the dam, but you should probably have an annual inspection done by an engineer, qualified engineer. And we're also suggesting that every 5 or 10 years that an engineer go do a top to bottom inspection and evaluation to look at the original design assumptions, evaluate the spillway conduits, geotechnical conditions, slope stability, foundation, seepage, and just to avoid the issues like happened at Oroville Dam a few years ago. A spillway had been in place for 50 years, was improperly designed and constructed, but nobody knew that because they never went back and looked at the records. Certainly you need an engineer to assist with preparation of dam breach inundation maps. And it helps to have an engineer work on the emergency action plan, especially the trigger elevations, to determine when people downstream might need to be notified that there's a situation developing at the dam, or when they might need to be evacuated. And there's a timing component there that the engineer that does the hydrology and hydraulics needs to be involved in setting these trigger elevations, depending on how much time it's going to take to close roads and evacuate people. There are 16 NRCS flood control dams in Maryland. We call them PL 566. They were designed and constructed with Soil Conservation Service technical assistance and funding, usually back in the 1960s and 70s. There are some funds available from NRCS for addressing deficiencies. Most of these are deficient in inadequate spillway or erodibility of emergency spillways. But NRCS needs to be involved. If NRCS is going to fund it, they need to be involved in the design and repair. And it's about a 10-year process from when you apply for funds and when you actually get it. There are some reference materials. Like I said, go to damowner.org for lots of information, and there's some other brochures. There's FEMA has a training aids for dam safety modules. They're on a DVD you can get from FEMA. It's slightly outdated. They were prepared 30 years ago, but there's still a lot of good information on them. NRCS website has a lot of good information. And I'm going to wrap it up with a thank you for attending today. And this is going to be goodbye for me. In a couple of weeks, I will be retired. And I have really enjoyed working with dam owners, engineers, other regulators, counties, and emergency management for the last 38 years. And as you can see, I'm going to be relaxing and taking it easy from here on out.
Hal, that was great. Thank you very much. And it's really a pleasure to have you presenting here today. We do have 5 minutes for questions. I believe we've captured them, and Jennifer can read them out.
Okay, let me start with the first question that I think is referencing a slide early on in your presentation, but I'm not sure which number, Hal. The question is, the dam height in the picture is measured in the interior of the pond. Should that be from the top of the dam to the invert of outfall elevation? I think it's before this. Keep going. Before this, like maybe 1 or 2.
There it is. Yes.
Okay.
So that is a very good question.
Yeah. Okay.
Are you finished with the?
Yes. Okay. Yes, I'm sorry.
Okay. So Maryland law, the dividing line between when you need a permit from dam safety or you can get approval from the Soil Conservation District is 20 feet at the upstream toe. The National Inventory of Dams measures the height of a dam at the downstream toe. And my arrow is a little bit sloppy on this particular slide, but this was just really to give you an idea how much water could be held behind this pond. It was a fairly large pond for a small pond, and it wasn't properly built. It was built by an environmental contractor that was good with landfill remediation, but they didn't know anything about stormwater ponds, and the engineer that was involved was an environmental engineer and didn't have any background in dam safety. The height of the dam measurement is a big issue that we hope to clarify. I think it might be in the guidance documents that John has put together and that are on our website now. And I think NRCS measures it to the middle of the embankment. So anyway.
Okay, the next question, Hal, is you mentioned CMAQ. The question is, what is a CMAQ device and what does CMAQ stand for? There was a written response that says CMAQ stands for Continuous Monitoring and Adaptive Control Ponds. Trademark names include Opti, Smart Pond, and Real-Time Control. Did you want to add anything to that, Hal?
That is what I intended in my comment, was there are some counties that are putting in smart pond features, these computer controlled Opti type devices on their stormwater ponds for getting water quality credits under their MS4 permits. And the point that I was trying to make is that you can't just slap one of these things on to a riser for a dry pond and make it a temporarily wet pond to get water quality without looking at the overall impact to hydrology and hydraulics and any changes to a dam under Maryland regulations. Any changes to a dam require either a permit or the Soil Conservation District. And sometimes these devices have been installed without any permits from MDE or authorizations from the Soil Conservation District. That's it.
Okay, the next question is a comment and a question. The comment is that most of the outfall failure I've seen is in one way or another related to pipe joint failure. So the question is there any revised standard for pipe joints?
Good question. The concrete pipe joints are supposed to be watertight. They have rubber gaskets in them. It used to be circular O-ring gaskets. Now they're shaped or profile gaskets, which have a certain amount of elongation. If the foundation settles, the joints can pull apart to a certain amount and still be watertight because the gasket is compressed in a groove between the two pipe sections. Corrugated metal pipes, maybe aluminum pipes, Sometimes you can have a flange connection. In MD378, where corrugated metal pipes are used, there's a requirement that a 24-inch wide rod and lug joint be used, not a hugger band or anything like that. It gives more gasket with a continuous rubber gasket under it, a 24-inch wide gasket for watertight joints. But we don't see as many corrugated metal pipes now as we used to. PVC pipes, I showed one picture of a brand new PVC pipe where the O-ring came apart. There's really not a good answer for that. You just need to make sure that you specify joints that can take some amount of movement and be watertight. You really don't want to glue PVC joints together because then it's rigid. If there's any movement, the pipe breaks instead of pulling apart at the gaskets. There's a certain amount of elongation for any of these joints that can occur and still be watertight.
Okay, next question. Will the slip liner installation reduce the design flow capacity of the original design, and how do we address this?
That's therein is a good question. That's why an engineer needs to be involved. If you're slip lining a corrugated metal pipe with a smooth plastic pipe, if the new pipe is not too much smaller, then the smoother interior of the plastic pipe makes up for the loss in diameter, and it may be able to maintain the same flow capacity. But if the pipe is much smaller than the existing conduit, maybe the existing conduit squashed, then yes, there will be constriction. The pipe may become orifice control instead of barrel control if it's really small. That's why we insist on an engineer to design it. You shouldn't just get a contractor says, yeah, I can slip line your pipe and put it in there and grout it without any consideration of the hydraulic effect.
Hal,
Yes.
Jennifer, it's approaching 11 o'clock and we've got more questions than we can answer. So this is a really good thing. But we're going to hold the rest of the questions on your presentation until we find some time later in the day. We do have a wrap-up Q&A where we can come back to these questions. So what we're going to do now is we're going to take a 5-minute break, and then we're going to come back with lessons learned from the FEMA Hhpd grant program from Vista to Law. We'll be back at 11:05. Thank you.
Can you see my 5 minutes slide, please?
Yes,
Yes.
Vista.
Super. Thank you. Oh, so. Good morning, everyone. Welcome to Maryland's Dam Safety Workshop. My name is Hhpd Dalal, engineering geologist with the Dam Safety Program. Today I'm going to talk about funding for dams. For a long time, you have seen that Maryland Dam Safety has always been there providing technical support, technical documents, technical workshops. So under the management of Jennifer Smith and Ray Barr, we have decided now to also bring to you some funding resources. And what I'm going to talk about today is going to be one of them, which is the High Hazard Potential Dam grant program that FEMA, Federal Emergency Management Agency, had started in 2019. They started this program to help the high hazard dams which are unsafe and needed the assistance, financial assistance. I have included in my first slide on the left-hand side, MEMA. MEMA is one of our agencies that we are working with on this grant. They are going to be the administrators, and MDE Dam Safety is going to be the technical coordinator for this grant. So a little bit of background about this grant. It was started as an initiative by President Obama in 2016. He signed the WIN Act in December 2016, and the goals were very clear. The goals were that we are going to help the high hazard dams which are unsafe, and we are going to protect the public which are going to be affected by these unsafe high hazard dams throughout the country. And so under the head of HS, Department of Homeland Security, FEMA, Federal Insurance and Mitigation Administration, and lastly, the National Dam Safety Program. This grant is based under these headers. The authorizing authority for the program is the National Dam Safety Program Act, which provides technical assistance, planning, design, and construction assistance in the form of grant to rehabilitate the unsafe high hazard dams. I emphasize unsafe and high hazard because they are only meant for those two, not just for high hazard dams, but the dams which are unsafe throughout the country. In 2019, this grant was started by FEMA, and they issued a $10 million grant award throughout the country to all 49 states. Alabama is only the state that does not have a dam safety program, and so they do not qualify. This grant has a lot of strings attached, and one of the things that I'm going to be very forthcoming and honest with you is to provide you with some of the things that need to be accomplished before this grant is awarded to the recipient. In 2020, last year, for the first time, Maryland applied for this grant. Again, there were only $10 million approved for this. And in 2021, this year, we have heard that they are going to have $12 million assigned for this grant. So what are the objectives for the Hhpd grant? They will provide assistance to repair, remove, rehabilitate eligible high hazard potential dams which are unsafe. They will protect the federal investment by asking for operation and maintenance plans for 50 years after this grant is issued. They encourage the state and local governments to consider all dam risk in the state and local mitigation planning. It reduces the potential consequences of life and property of Hhpd incidences. It incentivizes states to incorporate risk-informed analysis and decision-making into the dam safety practice. This is something that Maryland has not been very forward with, but we are thinking about getting these things done sooner than later. This grant will reduce the overall number of Hhpd dams that pose unacceptable risk to the public throughout the country. It promotes a program where emergency action plans are prepared and exercised. We have regular tabletop exercises and we have functional exercises that we do. So this grant is going to push the dam owners to prepare the EAPs and to exercise them. And lastly, it will reduce the cost to rehabilitate those dams after this money has been issued to them by using new solutions and technologies. Now, this is the $1 million question. Who is eligible for this grant and who is not? All federal dams are not eligible for this grant. Dams built by USDA, Department of Agriculture, those dams are not eligible. Projects that increase water supply storage capacity, they are not eligible. You cannot use this fund to just do regular maintenance and repairs to your dams, even though they are high hazard dams. Any modification to a dam that does not improve the safety of the dam, that's a big condition. And the onus has been provided to the dam safety program for each state. We have to determine if that dam is unsafe or not. And we go through the whole rigmarole to find out if those dams are unsafe. And only then we make them eligible for this grant. So it's a very intricate and detailed process by which the dam safety program delineates the dams which are eligible for this grant. Licensed hydroelectric dams, modifications to produce hydroelectric power, those dams are not eligible either. So what dams are eligible? Well, the eligible dams have to be in a state with the dam safety program. For Maryland, we have a dam safety program. Other 49 states, 49 out of 50 states have dam safety programs. So those projects in those 49 states are eligible, except for one, which is the Alabama. They have to be classified as high hazard dams by the Maryland Dam Safety Program. And it has to be on our dam safety inventory also. They have to have an emergency action plan, updated and approved by Dam Safety Program. Maryland Dam Safety Program has to determine either of the two criteria. The dam fails to meet minimum dam safety standards of the state, or the dam poses an unacceptable risk to the public. Structural and non-structural rehabilitation of eligible high hazard potential dams, those are eligible. Also, the dam owner has to prepare an operation and maintenance plan for the next 50 years after the grant is issued. And there is a commitment with FEMA. And they have to participate and comply with National Flood Insurance Program. Again, this list is not exhaustive. I have given some references at the end of this presentation that we would like the owners to check out and see if there are any other criteria that you have to meet to be eligible for this grant. So the FEMA agency is responsible. They administer the grant. The money comes from them. And they issue a NOFO, Notice of Funding Opportunity, every May or June. There are plans to do this every year. FEMA had said they are going to do it this year. So we shall see. We haven't received the NOFO for this year yet. They will provide technical support. They have got a lot of people there who can help us, and we approach them for any kind of technical or funding questions. They will approve the hazard mitigation plans. They will approve the flood management plans. They will consult with a National Dam Safety Review Board to see which dams in the state qualify. Just because the dam safety program says so doesn't meet the criteria. They will go and check with the National Dam Safety Review Board also. They coordinate with our sister agency MEMA and with MDE to make sure that all the I's are dotted and all the T's are crossed before the award is given. So working with FEMA has its own ups and downs. What is the role that MDE plays in this grant? We are the technical coordinators. I am the manager of this grant at MDE. We develop and prioritize the list of unsafe dams, high hazard dams in Maryland. Last year, we spent a considerable amount of time going over the dams we thought were unsafe. We read through the reports, technical reports. We talked to the managers of the dam, made sure they were aware of this grant, as well as they wanted to work with us on these projects. So they were on board to apply for this grant because there's a big commitment from them to do all the things that I'm going to go over. The first thing is there's a cost share of 35%. So it can be in cash or in kind. And the dam owner has to make the decision whether they have the resources and the time to commit to this funding. They need to have an updated EAP we talked about. They also need to have a county-wide hazard mitigation plan. Now, if you don't have that hazard mitigation plan, that's a lot of time investment as well as the cost. And lastly, flood management plan. You also have to have that before you can apply for this grant. FEMA will work with you in giving you a 1-year extension if you do not have these plans available, but that has to be in writing with them. MDE issues a notice of interest to see if the dam owners are interested, and we get some commitment from them. We will assist the dam owners in putting together the technical documents, the grant application, and working with MEMA. So as a dam owner, you'll be working with MEMA and MDE for our respective roles. And we'll work with MEMA to provide them with the technical updates, technical reports that the MEMA will take and submit to FEMA. This is the notice of interest. It's very small. I understand you cannot read all the items in here, but the reason I put it here is because there's a lot of things that the dam owner has to commit to. It has to be in writing, because if they do commit initially and then they walk out, then we are depriving other dam owners who have the resources to vie for this grant. So we want some firm commitment from the dam owners that they are interested in this grant and they have these kind of items ready or committed, approved by their management. So what is MEMA's role? MEMA is our administrator, and we are very happy that they are on board because we do not have the resources that MEMA has. MEMA works with FEMA on several grants. So they have the medium of not only communicating with FEMA readily and efficiently, but they also have the grant application process down path. They know how the money comes in, how the money goes out. And so we are very happy and appreciative of MEMA's role as an administrator of this grant, and we work closely with them. So what MEMA does is they will provide and coordinate with us on NOFO that FEMA gives out. They submit the applications to FEMA. They also have expertise in hazard mitigation. And so when the counties submit their hazard mitigation plans, they submit it to MEMA, who reviews it and comments on it, because they have a whole program over there on hazard mitigation. So they are very well versed with hazard mitigation and flood management. And so they are a great technical resource for us, as well as for the dam owners who want to apply for these grants. They deal with all kinds of FEMA computer connections that they do. They have the hubs where they upload the documents, which we don't at MDE, we do not have. So they are very useful to us in that respect also. So now, if you want to be an applicant, what are your responsibilities that you have to undertake? Or you have to realize that these are the things that are expected from you before the award letter comes to you. You have to work with the state dam safety program. And luckily, Maryland has the dam safety program, and we have a list of unsafe high hazard dams that we can work with. You need to have a hazard mitigation plan. If you don't, you need to start working on it because there's a lot of cost involved, a lot of time involved in putting this together if you don't already have it. And I've heard some numbers. It is not very cheap to work on hazard mitigation plan. It takes a while. It takes a cost. You need to provide operation and maintenance plan for next 50 years to FEMA if you are an awardee of this grant. You have to comply with CFR 42 section 519(6)(j)(9), where all the laborers and mechanics employed by the contractor will be paid the wages which are determined by US Secretary of Labor. You should have a flood management plan already, or you can apply for a 1-year extension with FEMA. They will work with you on that. Grant flood allocation. How are the funds allocated? $10 million for 49 states, and each state may have 6, 7, 10, 15 applicants. How is the money divided up? It's a drop in the bucket, but still, for some dams, some projects, that money is a good starter. It could take the project from the start to finish. So, 1/3 equal distribution among states that apply for grant. If 30 states apply for this grant, $10 million is equally distributed. 1/3 of $10 million is equally distributed over the 30 states. And then there is an equation that they use is how many projects have been sent to FEMA, and they divide up the 2/3 of the amount remaining between those projects. The period of performance is 36 months. You need to be able to finish this project within 36 months from the start when the award is given to 3 years after that. Oh, there's a cost share that I didn't mention over here. There's a 35% cost share that needs to be undertaken by the dam owners. It could be in cash or in kind. So in 2019, we got the information about this grant pretty late. So we didn't apply for this grant in 2019. But by 2020, we had our things together. And so we did apply for the 2020 Hhpd grant. And how do we come to the conclusion that these are the projects that qualify? So we had initially about 20 projects. We went through different criteria by which we brought the numbers down to six unsafe high hazard dams that qualified on several factors. One of the factors that we use is people at risk. And how many people are going to be put in harm's way if this project or if this dam were to breach? Another criteria we used was the reports that were done on that project. And we go through which dams have got problems and which dams can wait for some time. Then we communicate with the dam owners. It's not just our decision, it is a decision by the dam owners to commit themselves and their resources and their agencies to this process. It's their dam, they make the decision. And therefore, we have that notice of interest that we want the dam owners to fill out and send to us that they are really committed, they are serious about applying for this grant, and they have the resources to do all kinds of pre-application work. Maryland, luckily, was approved $274,176. And the cost share of that was $147,629, which is a 35% match provided by dam owners. When we divided up this $274,000 between 6 dam owners, the amount was very less. And so we lost 3 dam owners or 3 projects. They didn't think the money that was being given to them was large enough to commit to other things. And so they dropped off. Finally, only 2 dams or 2 dam owners were eager to pursue this. One of them was about to drop off, but somehow they talked to the managers in their program, and they came to the conclusion that yes, we will vie for this grant. Even though it's a drop in the bucket, we will go for it. So now we have 2 dam owners who are going to be provided with this grant. But still today, this is middle of March, they still haven't received the award letter from FEMA. We applied in September of 2020 for this grant, and it has been over 6 months, and still the award letter has not been received by these dam owners. So we have to work with FEMA. So after all said and done, what we have learned from this process, I'm going to be very honest with you. This is no, all this glitters is not gold. Even though they have $10 million, it's distributed over 49 states with so many projects that vie for it. You need to have a lot of backup work done. You need to have hazard mitigation plan ready. You need to have flood management plan ready. You need to have EAP ready. You need to be listed under unsafe high hazard dams by the Dam Safety Program. The repairs should improve the overall condition of the dam to mitigate hazards to public. It's not just for the repairs to your high hazard dam. It should improve the safety at your dam. And you cannot use the grant for maintenance and repair purposes. So before you all, I'm not trying to say that you should not apply for this grant, but if you do want to apply for this grant, I want to make sure you understand that these are some of the requirements by the federal government for this grant. There are a lot of strings attached. I'll be the first to say that, but we are here to assist you. And this is not the only grant that we are working on. Jennifer, Ray, myself, we are working on to get other projects, other grants into MDE. Hopefully, they don't have too many strings attached like this one. But when we do have other grants, because we know the cost of repairs to the dams is astronomical, and we'll do everything possible to bring those grants to you to help you repair your dams. These are the references that I mentioned. I believe we are going to give you these slides as a PDF files later on after the conference is over. So you should be able to go there. This person, James Demby, he's the grant manager, Hhpd grant manager at FEMA. I put his email address if you have more information, but these 2 websites have got tons of information there. Please check it out so you understand and you appreciate what this grant is all about. I'll take any questions now. or even afterwards, you have my email address, my phone number. Please give me a call if you're interested in applying for this grant. Thank you.
Visti, very good presentation. Thank you. It looks like we do have one question and we have time for it.
Actually, we have a couple questions. I'm going to start with, I'm not going to necessarily take them in order. Visti, the first question, Maryland has a hazard mitigation plan. MTA has items on that plan, as should most state agencies. Would this meet the criteria? I think this is the criteria for having a hazard mitigation plan for in your county or locality.
Correct. The authority on approving these plans, first round of approval would have to come from MEMA. MEMA has the resources, they have the technical know-how, they have a whole program, hazard mitigation program. So if you send it to me, I can run it by my contact at MEMA and we'll get you any comments or any kind of revisions that are needed. I'm glad that you have this. We will be able to work with you on this mitigation plan and get you some advice from MEMA.
Okay, there's another question here. If the estimated cost for the studies, design, permitting, and construction is $1.5 million, does the dam owner have to have all of his financing and funding for the amount above and beyond the grant award in order to be eligible for the grant?
Not all of them, but at least there has to be a commitment that you will find the resources in the next 3 years to pay your cost share for this grant. So 35% of whatever is approved by FEMA for your project, you will have to bear that cost, whether it's in kind or in cash.
Okay, looks like the last question. It looks like the Hhpd grant application dams are mostly owned and maintained by a county. How can a county apply for this grant?
Well, the county did apply for the 2020 grant. I won't name which county it was, but they did apply and they went through the same thing. They are the dam owners and we don't differentiate between a private mom and pop dam owner or a state or a county. So you're eligible just like anybody else. So please apply.
Okay, with that, we're going to go ahead and take our 5-minute break. Next up, we're going to have John Roach, and he's going to be covering Permitting Process 101. We'll see everybody back here at 11:40.
All right, welcome back, everybody, and thank you again for attending our session this week. We've got about 280 persons at any given time who are live and listening, and that's great. It's a great opportunity to share some knowledge and have some good conversations about the state of dams in Maryland. So what I'd like to do right now is talk a little bit about permitting for dams and small ponds. This is one of the key reasons why we launched the permits division late in 2019, early 2020, was to hopefully demystify the permitting process, develop some process improvement strategies internal to MDE to make it more efficient if possible. And one of those is, providing roadmaps and education and outreach to dam owners and their engineers so you know what to expect and what to submit. So let's get into it. The first question, one of the first questions we receive a lot is, well, why do I need a permit? Given the description of your work or just overall, why do we need dam safety permits? Well, throughout human history, or history, I should say, humans have acknowledged that there is some level of risk associated with the storage of water. It could be the scarcity of water. It could be the lack of having water. It could be too much water, flooding, or things like that. So there's always been some, I think, innate understanding that water and risk can be associated. In the 1930s, early 1930s, the state of Maryland formed the Water Resources Commission to address that exact concern. There had just been a prolonged period of drought, so there was risk in terms of water scarcity. And our neighbors to the north in Pennsylvania, and then also out in California, among other places, had suffered some really catastrophic dam failures. Think about the Austin Dam in Austin, Pennsylvania, or the St. Francis Dam, which killed over 400 people in outside of Los Angeles. So the Water Resources Commission was formed. They recognized that dams are critical infrastructure. Right off the bat, we actually looked at some of their meeting minutes from their first meetings, and that was the second item they talked about. First was, hey, we need to worry about water. Second was, hey, we need to worry about dams and how they're designed, constructed, and operated in the state. So we've been regulating dams in some form since 1934. In fact, the law, while the language has changed, or maybe the citation has changed slightly, it's still largely the same. It still says that a person shall obtain a permit to construct, reconstruct, repair any reservoir, dam, or waterway in the state of Maryland. And that language is important there too, because notice it specifies reservoir as well as dam. So changes in the area that's being impounded by the structure could trigger a requirement for a permit as well. So this regulation, it provides the state with checks and balances to ensure the needs of water users as well as the downstream public are protected. Permitting helps ensure that alterations for a dam becomes part of its permanent record, right? These structures last for not 5 or 10 years, but decades, maybe centuries or longer. And we keep a permanent record on each dam, and we refer back to that, or owners and their engineers refer back to that history as they're doing a rehabilitation or repair project, because it enlightens you on how this project was constructed and operated over time. Permits also provide the opportunity for public comment. People should be aware there's kind of a community right to know. If you're building a high hazard dam in their community, people at least need to be aware of that risk that exists out there. Now, in our current format, our permits that we issue in dam safety also serve as an operating permit. So some states do it differently, where they'll have an operating permit, which is different than a construction permit. At the moment, ours is one and the same. So when a project is done being constructed, the permit doesn't go away per se. It lives on through those operating and maintenance obligations for the owner. So that's how we ensure that dams continue to be operated and maintained acceptably. And, lastly, I do want to point out that the permitting process, our review or approval of a permit by the Dam Safety Program in the state of Maryland doesn't absolve your engineers of being familiar with or employing the state of the practice or having a good design. That is always paramount. It's always the designer really who shoulders that burden of ensuring that the design meets the needs and the foreseeable requirements of that dam. All right. So if that's kind of the why behind needing a dam safety permit, when do you need a permit? And that's a really good question, because not every activity needs a permit. And in fact, we have the distinction in the state of Maryland that we have what we call dams and small ponds, and they're handled differently as well. So let's dive into that. So a permit is required when any change is made to a dam, levee, reservoir, or there are pertinent works. So pertinent works can mean things like a spillway, a plunge pool, and an auxiliary spillway. And this can include things like adding a forebay, perhaps, performing soil borings, or adding some of that smart stormwater management technology that Hal touched in his conversation. Permits can be required when there's in-kind replacement of certain existing components. It may depend on specifically what that component is, but certainly some are more critical and need to be reviewed more thoroughly than others. Permits are required for dam removals, and sometimes permits can be required for what we would traditionally think of as a road culvert. And we have a policy memorandum that's out there. I'll talk more later today about our policy memorandums. But this has lived in Maryland 378 for decades as well. When a culvert, quote, impounds an excessive amount of water, basically an intentionally undersized culvert that acts as a dam. Lastly, permits are not required, and we don't want to add an additional burden for dam owners throughout the state for normal maintenance activities, right? That normal maintenance activity is something good. We should promote it and not hinder it. So things like mowing or debris removal in front of a trash rack, or perhaps removing the sediment for a stormwater management facility to ensure it retains its functionality. Those are what we consider normal maintenance activities and don't need approvals. We've spelled out a list of some of these normal maintenance activities in our policy memorandum number 11, so you can refer to that. All of these policy memorandums that we've discussed, that we'll be discussing today and on Thursday, are available on our website right now for you to refer to. So the question then comes to, is it a dam or a small pond? If you have a dam, you need a permit to be issued through the Maryland Department of the Environment Dam Safety Program. If you have a small pond, you probably can receive approval by the local soil conservation district. And notice the language is a little bit different there. It's an approval versus a permit. And there's some things in law that have some slight differentiations between the two. So how do you know if you have a dam or a small pond? Well, if the answer to any of the four following items is yes, then you have a dam and you need to go through permitting through dam safety. So if your height is over 20 feet tall, measured from the upstream toe to the crest, you have a dam. If you have a drainage area over 1 square mile, you have a dam. If you can store more than 50 acre-feet of water, and that's up to the brim-full elevation, you have a dam. And lastly, certainly, if you have a high or significant hazard structure, it's a dam as well. Now, if you answer no to all of those, it's a small pond, and you can probably receive approval by the local soil conservation district, or for state and federal projects through the plan review division here in MDE. But there are a few quirks in laws and regulations that we have to be aware of. So if you have a pond located in a Use 3 watershed, you need to get a permit from Dam Safety. Jennifer touched on this a little bit. We have a regulation change underway right now to remove this requirement and allow small ponds and Use 3 watersheds to be approved by the SCD. So that will change, hopefully in this calendar year. There is a law requirement that says any small ponds, dams or levees or otherwise, located in the Jones Falls, Gwynns Falls, or Herring Run watersheds within the city or county also need a dam safety permit. This seems to be a relic from an era before we had quantity management and stormwater, and it would require a law change, which is a little bit harder than regulation, but that's something that could be explored. I will note that Baltimore City, because they do not have a soil conservation district, would require and default to obtaining a permit from the Dam Safety Division. All right, we've covered the why do we need one. We covered the, what, now how? How do we get a permit? That's a big question we have, and we are, trying to put some FAQs on our website and more information to get this out there, because it still seems to be a mystery to some folks. So, and I'm going to talk here specifically about a permit through dam safety. I won't talk to the SCD processes. That is theirs to own and kind of, decide how you would do it. So you apply for a dam safety permit using the joint federal state application. I'm not even going to read it. We call it the joint permit application, or the JPA. I'm sure you're familiar with it. But I would say that most people don't recognize that that's also the permit vehicle for dam safety. So even if you don't have wetlands impacts or you don't believe you need waterway review, if you need a dam safety permit, you still have to file that JPA. That being said, remember, if you do have a dam or small pond on your project and you're filing that JPA, include all the dam related items in your application package, because that allows us to review it a lot quicker and easier, as opposed to having to reach out and ask you to submit that after it's gone through a few different hands and finally lands on our desk. Yes, the JPA still requires paper copies at this time. That's something that I think MDE is slowly but surely moving towards more electronic system, and we look forward to that. But if you do have dam specific files and it's voluminous and lots of pages, and you don't want to chop down a forest to put your project together, you can email them. We've set up an email address specific to dam safety permits, and it's listed right here, mde.dampermits@maryland.gov. So if you include your files as an attachment there or some kind of Dropbox download link, we can receive them and attach them to your permit when it comes in. I will note, and I'll probably mention this a few times, the landowner must sign the permit application. When we issue a permit in dam safety, the permit, because it has operation and maintenance conditions and other land restrictions, we issue it to the property owner or owners. So regardless if a county has an easement or a third party wants to do the work, the landowner needs to be involved in the permitting process. I'd also note that you want to include contiguous property owner notifications. And a lot of times people say, well, this is a repair job or a maintenance job, and there's boxes to check in the joint permit application, the second page, about type of work. Please check that dam or small pond box if you have one of those on your structure. It just helps ensure that when these are screened by MDE staff and then routed to all the appropriate divisions, it helps ensure that dam safety gets it. They're pretty good, but occasionally projects slip through the cracks. And, if it slips through the cracks and we don't get it, that's time wasted on everybody's part. So we want to make sure it gets automatically routed to dam safety. Okay, so that's the who, what, where, when, why, and how. Now we're going to talk about what do you need to submit. And that's another question we get a lot. And part of this has been addressed on our FAQ on our website, but we'll dive a little deeper. It's a common question that we get. So what do you need from us to get the permit? And I will note that, it does kind of depend on what you're doing, right? A permit to construct a brand new high hazard dam is going to be different than a slip lining project for a small dam or a concrete maintenance project on a medium sized dam. So it does depend generally on what the project is. That's why it's important to hire a qualified engineer and work on a mutual scope development. And when I say mutual scope development, I don't just mean between the owner and the engineer, but sometimes bringing dam safety in early is really important. It can help build familiarity with our understanding of the project, but we can also advise on scope or permitting expectations based on past project experience. Provide our best professional insight to help you make sure that the project will get off the ground and go smoothly. On occasion we hear projects and engineers say, we request information for review, and they say, well, that wasn't in my scope. And to be quite honest, that's not our problem. It's something we need to do the review, so we need to make sure that we avoid those issues when they come up or prevent them altogether, to make sure that what you need to submit is known early on in the project. That being said, here are some general submission expectations. Of course, you need detailed construction plans. We need to see everything that's being built. Project specifications are also crucially important. And I'll note that although Maryland 378 does have a, quote, specification section in it, that's hardly a specification for anybody who's familiar with actually reviewing specifications. And it's certainly not something that we're going to accept for a, quote, dam that is not a 378 structure. So you may need to modify those, beef them up, or create a whole project spec book. I will note we have some guidance documents that we're working on, hope to come out in the next few months, that will give you an idea or kind of a roadmap on what elements are appropriate for your project specifications. Next, I'll mention that we should have a basis of design report submitted for us. Oftentimes, and perhaps this is a pet peeve of mine personally, is we get the stormwater management report, but we're not reviewing for stormwater management. We're reviewing the dam structure itself. There's a lot of overlap, certainly, within the hydrology and hydraulics, but the stormwater management report doesn't give you a whole picture of what's being constructed often, and it's hard to dig through. So I'd like to suggest that everybody provide a basis of design report that submits a summary of the proposed work, a summary of the design standards you are believed to be applicable, a statement about the hazard classification. Please do a dam inspection for your existing dams. Inspect it and identify any deficiencies that need to be addressed as part of that permit. And then get into those detailed engineering disciplinary reports, the H&H report, the dam breach report, maybe there's a geotechnical or structural report. Please format it, think about what you're presenting to us in a way that kind of paints the whole picture from one end to the other of a project review. It helps facilitate our review a little bit easier. It acknowledges that you're not just, doing this for stormwater management without considering the other elements of the project that need to be thought of. An operation and maintenance plan should be developed for your dam as part of the permit. And we do have a template. It's kind of a template that we developed available on our website that's, I wouldn't say one size fits all, but it's scaled for a big dam, and you can easily cut a lot of it out to make it applicable for a small dam. So there's sometimes more content in there than you need, and you can right size it down. But we have that available as a starting block for you. If you have a higher significant hazard dam, we're going to need to ensure that the emergency action plan is either created or up to date. We need a memorandum of land restrictions, and we'll describe the memorandum of land restrictions a little bit later. And then an engineer in charge affidavit and resume as well. Okay, so another question we get is, what are the design standards we may be held to? And a lot of times people see Maryland 378, the pond code, as the only document that the state has that really is a design criteria. And that's specific to small ponds though. So I would say be careful, use caution. It doesn't always translate to a dam that would be permitted through our office. So as I'm looking back and talking to people and learning from their experiences, I see that COMAR, our regulations, were really written with the intent and the understanding that the dam safety engineer who would have experience and qualifications would be aware of the appropriate national or sometimes other federal design criteria. Maybe that's Army Corps Reclamation, the Federal Energy Regulatory Commission, or NRCS, and they would take that and apply the correct design criteria to that dam. That's as my understanding is, that's how we were kind of set up as a state. So as opposed to having our specific criteria, we kind of hung on the coattails of those federal agencies who developed some really good guidance. That is my understanding of why we don't have a specific you shall do X and Y and Z. So that being said, it does leave some gaps, right? We can advise on accepted criteria and practices, and we are working on these policy memorandums and guidance documents and regulations because I think it's time to close this gap and make it understood of a little bit better the roadmap of what we're looking for design criteria. So again, I'll point you at the moment to the policy memos for more guidance. For design standards for small ponds, I will note USDA NRCS Pond Code 378, which is woefully out of date. We're working on that. Is the current design standard for small ponds. I will say if you're getting a permit from the Dam Safety Division, that we will look to have the breach analysis performed in accordance with the dam safety criteria on our website. We'll look to see that precast risers are monolithic, that is, the base and sidewalls are all one piece. That's not explicit in 378. That's been our long-standing practice. And lastly, anti-seep collars are a no-no. They've basically fallen out of favor from federal agencies in many states, now going on almost 40 years. So we're looking to see filter diaphragms be used. All right, let's talk a little bit more about the engineer in charge. Hal mentioned this briefly earlier. The engineer in charge is a regulatory requirement, and they're basically responsible for ensuring that the design and construction conforms to the high standards of competence and the specialty of dam design and construction. For all of us who are engineers out there, a lot of this stuff wasn't taught in college. It's experience gained through mentors like Hal Van Aller, who we're going to miss so much, and other colleagues, knowledge sharing, educational seminars like that. So we're looking for that engineer in charge to have obtained that experience during their career. And we want them to be responsible from project planning to construction closeout. One point of contact, so that let's say a design change needs to be made in the field, the person who's aware of all the design considerations during the project planning should approve that design change in the field, because if you make that design change without referring back to the designer, you may be missing something. There may be a gap there, and that can cause problems. And this engineer in charge is also responsible for coordinating periodic inspections of the construction, documenting the work, and preparing the completion documentation as well. All right, the Memorandum of Land Restrictions. I want to talk about that also briefly because it's kind of a mystery to some folks. The Memorandum of Land Restrictions is actually required by law when you get a permit from dam safety, so it's not something that we can waive. It's a document, it's a legal instrument that's filed with the land records on the property or properties upon which the dam is located. And basically what it says is that as a dam owner, I affirm that I will abide by the applicable laws, regulations, and permit conditions, provides right of entry for dam safety to perform our necessary duties. But most importantly, we think, is that it helps ensure that future owners are aware of their obligations. So when they do a property transfer and perhaps there's a title search done, which is fairly standard practice, this should come up flagged to that parcel, and the owner will be able to be aware of their obligations. That's so important. As Jennifer mentioned, these farm ponds, which are passed from farmer to developer, now to HOA, there's a disconnect and people lose the understanding of what their obligations are. Because it runs with the land, it must be signed by the dam owner. And I will say that certain entities, I don't mean to say they're more sophisticated or not, but some owners, because it's a legal instrument, will want to go in depth and have this reviewed by lawyers and do deed searches and all that stuff, and it can cause project delays. Some owners sign right here and get it notarized and they'll send it off. So be aware as you're planning your project, get that MLR out there early, not at the last minute. Some common pitfalls in the application process. Let's talk about a few of these. First of all, as I'm mentioning a few times here, application and MLR signed by the property owners. That's a must. So please ensure that when you submit it, that's happened. Also, we see a problem where some persons look to solve a specific problem that they've been hired to do, but the dam has many other deficiencies. And it's our policy that when we issue the permit, those deficiencies need to be addressed. So let's say you're working on a slip lining project to handle a spillway that's deteriorated, but the dam is covered in a forest of trees. Well, we're not going to issue the permit unless you include the remediation of those trees as well in there. Again, I'll mention the stormwater design report. Although it contains much of what we need, it may not always be adequate. So include in your reports, and this is sometimes this is a thing that we see. It's not universal, but I do want to say sometimes we receive reports that basically just transmit all of the analysis to us. And you get a 100-page report or more, and it's just HEC-RAS outputs, hundreds of pages of HEC-RAS, hundreds of pages of TR20. You know, that's great, and we often want to see that, but we want to see the engineering evaluations and recommendations that are contained in that report, not just the data dump. And we want you to tie your evaluations and recommendations to that data. So you can say, refer to the HEC-RAS output on page 223 to see where you're getting a piece of data from. It helps us facilitate reviews a lot easier and shows that you have the knowledge to transform data into action. I'd also recommend, and I say this lovingly as a geotechnical engineers are the worst on this. We put really excessively conditional statements oftentimes in our reports where, you know, we're early in the design project, maybe we don't know where a footing or bottom elevation is, and we say, if this all remains true, then this is probably still adequate. If we see really excessively conditional statements in reports, realize we may sometimes ask, okay, could you please go back and verify with the engineer that that statement that was made 6 months, 12 months, 18 months ago early in the project is still applicable to your current design. Get that confirmation. Lastly, I want to say that while older plans, reports, and analyses are a huge wealth of information, reliance solely on those documents may not be acceptable or adequate. Things could have changed, hazard creep, you know, we've got old methods of analysis that may not be appropriate anymore. So use those, but remember to verify with updated current analyses. Okay, so we're coming close to the end of the conversation here, and the people always ask, well, how long is it going to take to get my permit? You need it now. I feel you, I understand that. As we all know, there's elements of work that add time, and there's elements of work that reduce time. You know, clearly, we're all working under the stresses of COVID, working from home, dealing with childcare issues. You know, that is a universal time adder, let's say. But we also have things that slow our work down, so I'm pointing them out just so that we can all, you know, right the ship a little bit. So things like the completeness of the application can slow us down. If we don't receive something that's not complete, it takes us longer. Also recognize that we have obligations to do coordination with other agencies and public notice, and those, because they're somewhat out of our control, can add time, and we have to factor that in. Lastly, of course, we all struggle with it. It's maybe not the best excuse, but our workload and permit volume can affect our turnaround times. And Jennifer mentioned we're down quite a significant number of staff right now, but we are hiring and we're advocating for more staff. So things we're trying to improve is education and outreach like this, so you have a little more awareness. Our policy memos to help provide a better roadmap for expectations. And then we're doing things like internal process improvement just to streamline work. We're looking for a continuous improvement here, right? We don't want to just sit and sit and sit and then all of a sudden launch a whole new system that may be great. We want to do incremental improvements. That's kind of the motto of our Dam Safety Permits division. But that being said, let me shed some light on actual permit turnaround times so you have an understanding of what to expect. So I've got two charts here. One chart is about for when we receive a permit application and we can exempt it because it's a small pond, able to be reviewed by the Soil Conservation District. The second chart will be if we issue the permit. Let me explain what you're looking at here a little bit. On the vertical axis is the median permit turnaround time. Median, not mean, because this is not a normal distribution. That's more appropriate if you're a statistics person. So we're looking at the turnaround time in days on the vertical axis. And on the horizontal axis, we're looking at the number of applications received by our division within a calendar year. So clearly, the more applications received, you would think that would have a drag on our turnaround time. Lastly, what I'm showing you here, these bubbles, which are scaled to our staffing, right? So a bigger bubble, you would expect we have more staff and more capability to process permits quicker. But let's look at it a little bit. It's interesting, I see, is that in years 17, 18, and 19, 2017 through 2019, and I don't have this for 2020 yet, our volume of applications increased significantly compared to the previous years. Now we're dealing with between 150 and 200 applications a year, whereas prior to that, we were seeing at most 100 per year. So we're seeing a lot more applications received. You'll see that we've staffed up, though, in response. And overall, that has driven our turnaround time down. You look at 14, 15, 13, we were in the 50 to 90 days median time to do a permit exemption. Now we're looking in the 20 to 50 day time frame. So we've seen some improvement. I'll note 16 is an outlier because, we did a course correction. In fact, we realized that perhaps we were too rushing to exempt projects and realized that maybe we're exempting things that needed a closer look. So that's when we released our breach analysis guidance and did some course correction to understand that we're providing the adequate review that we're expected of and required to do. Okay, so permit turnaround time. Now we're looking at this same setup. Median turnaround time on the horizontal axis, although the scale is a little bit larger, and the number of applications received. Again, you'll notice we've staffed up in response to the larger amount of permit applications we've received. Unfortunately, those FTEs, you just see the number after the calendar year is our annualized full-time equivalents and staffing. It's now dropping below that 7.5 we've seen before, but we've been able to drive down permit turnaround times. But this gives you an idea of approximately how long it takes for a, quote, typical project if we receive everything that we need to in a timely manner. I will say, though, let's say you are building a brand new high hazard dam, starting from scratch. A perfect example was in 2016 with the Mount Soma Reservoir in Harford County. It took, I think it was like 2 years and 3 days exactly from when we first started talking about the project. This is before they had even selected a site to issuance of the permit. But there's so many things. We've talked about the pitfalls and other issues that can slow the turnaround time down. So it's a shared job, right? We're trying to do our best to be efficient and turn things around and respect the rules and regulations and safety of members of the state. But the better we can get from applicants, it helps us facilitate being efficient. All right. Lastly, what to expect once you have a permit. So the EIC, again, we're expecting the engineer in charge will remain engaged, oversee construction. We'll probably want to have some kind of pre-construction kickoff meeting to make sure that everybody on site understands permit requirements. Weekly progress reports are really important and they're a condition of the permit. And we look at them when they come in, and we're trying to be a little stricter about expecting when you get those to us, because sometimes we catch things that others may not, or we have questions. And if we don't get a progress report about, let's say, maybe a loose or unsuitable zone in the embankment until a month later, that could be buried on 20 or 30 feet of soil, and we've lost the opportunity to step in and solve a problem. So weekly progress reports, documenting field work. You'll see here a young Mr. Hal Van Aller doing a slump cone test for concrete replacement in 1974 at the Pioneer Run Dam in Carroll County here. That's the kind of stuff we want to see. What are the reports of that slump result? We want to be informed of progress and submittals by that engineer in charge. We don't necessarily need to be in the review loop, but we want to see what's coming in and have an awareness again, we can document it. If changes are requested or required, it may require a permit modification, so please be aware of that. And then on completion of the report, we're looking for a request to begin use, the project completion report and certification, and the as-built as well. So that's what we're looking for as we see the project through completion. And later on in these seminars, we'll talk about what's the role of engineers and dam owners as you operate and maintain your dam after it's been constructed. So that's what I have for you. Thank you so much. I haven't gone over time, I hope. If we've got time for questions, I'll gladly take them. If not, we'll go this afternoon, or you can always reach out using this contact information.
Hi, John. Very good presentation, and it did generate numerous questions, and we have about 5 minutes to go through them.
Yes, and as John said, if we don't get through these questions, and there's other questions that we haven't been able to get through yet, we will try to address them at the end of today. So John, the first question that you have is, does removal of larger woody vegetation count as normal maintenance when larger stumps and root systems need to be cleared?
That's a great question. We have actually one of our guidance memos, I believe it's number 1, in fact, discusses that. We have had, I believe this policy memorandum 1 kind of expanded upon a policy memo or policy that was available on our website. I think it was initially written in the early 1990s. So not really a change in policy, just a, freshening for today's standards. The idea is that depending on where you are located on the dam, and depending on the size of the tree, removal of those roots may be more or less important. So we spelled it out in that guidance. But if you're going to the point where you're removing root balls and then having to replace fill in a compacted manner, yes, we would look for a permit or a small pond approval to do that work to ensure that it's done properly.
Okay, John, are there any permits needed to drain a pond if no other work is proposed? This may be to drain a pond before construction project is to begin or for other purposes.
That's another great question, and I've fielded a few of those in the not too distant past here. The answer from dam safety is no, but I don't speak for our entire department. So you may need to discuss that draining with the Wetlands and Waterways program, or perhaps even the industrial discharge folks for that type of discharge. Typically, this draining of a pond or normal spillway operation wouldn't be considered industrial discharge, but it does kind of depend on the means and methods. One thing I will note is that, well, 2 things is, first, when you're draining a pond, absolutely make sure that you're not pumping so much water downstream that you're causing flooding or damage to downstream properties. That would be a shame, and that could get you in a lot of trouble. Secondly, I would also note time of year restrictions depending on your stream use class. And particularly if you're in a more sensitive stream like a use class 3 or 4, consult with DNR on the time of year restrictions, because pumping down that water, you need to make sure it's not sediment laden and muddy, of course, but pumping down that water, whether it be superheated or a high volume, could have detrimental effects to aquatic species in the streams. And again, if you hurt those, you could get in trouble. So again, from dam safety, no, but from other people, you should check in and be sure.
Okay, this is a kind of a longer question. Say, for example, that one dam has to have multiple repairs that requires a JPA for each repair. Does the Memorandum of Land Restrictions have to be signed by the owners for each JPA, or does one recorded Memorandum of Land Restrictions suffice?
Thanks for that question. So if it's one complete project, you wouldn't necessarily need to submit multiple JPAs, but I suspect that the question is more geared towards, let's say in year 1, you're doing a slip lining project, in year 2, you're doing tree removal, in year 3, something else. So 3 distinct projects would likely require 3 JPAs. And the advice we've received from the Attorney General's office at MDE is that yes, the language as it's written in law does require a new MLR for each time we issue a permit. So that does capture any unique conditions or changes in the permit conditions or laws and regulations that could have happened from the time the initial permit was issued to subsequent permits were issued.
Very good. Thank you, John. We're going to have to wrap up now with this session, and we're going to pick up in 5 minutes with Hira Shrestha. He's going to be talking about dam ownership and enforcement issues. Again, we have 3 or 4 more questions that you probably see in the live event Q&A. We'll pick these up during the closing remarks Q&A session at 1:30. Okay, we'll see everybody back here at 12:25. Okay, great, Hira. We can see your presentation, your 5-minute break. Hira, do you want to check out your mic during the break?
Mic.
Testing 1, 2, 3.
1, 2, 3.
Okay, you sound
Okay.
good. Yep.
Okay. Okay.
Hira, you may go ahead and get started when you're ready.
So I'll go started. Okay. My name is Hira Shrestha. I'm working on this Maryland Dam Safety Division since 1 year, 3 months back. Today I'm talking about dam ownership, enforcement issues. In my presentation, I will try to cover who is the dam owner and the dam owner responsibility and liability, and how dam safety handle if there is a problem. Basically, I will talk about some enforcement issues in 2020. Okay, first of all, so what is the dam? So dam definition part Code of Maryland, is that dam means any obstruction, wall or embankment together with its abutment and appurtenant works, if any, in, along or across any stream, heretofore or the hereafter, constructed for the purpose of the storing or the diverting the water or for the creating the pool upstream of the dam as determined by the administration. So purpose of the dam, it might be for the public drinking water supply, might be irrigation, flood hazard control, recreation opportunity, and it might be power generation and stormwater management facility. And there are 3 types of hazard classification in Maryland: high, significant, and low hazard. And this dam hazard is classified as a downstream hazard condition if the failure of the dam occur, not the structural configuration of the dam. The high hazard dams means the probable loss of human life, and there is the probable of extensive property damage to residential, commercial, or industrial building and the downstream roads. Whereas the significant hazard dam, the possibility of loss of life and possibility of the property, road, and building damage. Whereas in a low hazard dam, the loss of life and the property damage is unlikely. There are 102 high hazard, 142, 48 significant, and 358 low hazard dam in Maryland. All total 627 dam. Now the question is, who is the dam owner? And the owner of dam is considered to be anyone who owns any portion of the dam, reservoir, or appurtenance work for the dam. And this is generally determined by using the property boundary and the owner information shown in the tax maps from the Maryland Department of Assessment and Taxation. And who will the dam owners? So type of the dam owners are might be federal, state, county and local government, water companies, private corporation, homeowner association, and there will be multiple dam owner if the dam is owned by the multiple property owner, and this is individual owner. Now I'm talking about dam owner responsibility. So dam owners should need to know the basics of the dam, and they should regularly inspect the dam, and they need to do the operation and maintenance of the dam in a safe and effective manner. They must understand the current laws and regulations associated with the dam, need to the public safety around the dam, and knowledge about the risks and liabilities associated with the dam ownership, and develop and update the EAP for the high and significant dam, and hire the qualified dam engineer for any engineering works. And they should be capable of financial planning to ensure the adequate funds are available. So knowing the full knowledge of the responsibility, the owner can reduce likelihood of incident in the failures, and they reduce their own liabilities, and they can improve the safety of dam and help to reduce the risks of the community. So dam owner liabilities, the dam owner is liable for the damage resulting from the dam's misoperation or the failure that would result in the sudden release of water to the downstream. Then the owner can face the reconstruction cost and possible liability for the downstream damage. So safety maintaining a dam is like a key element to preventing the failure and limiting the liability that the owner could face. Resulting dam failure, losses on the own valuable assets, and there's a loss of might be loss of life, a downstream property damage, and there might be the environmental impact, and there might be the loss of usage. Liabilities can be minimized by avoiding the negligence and obey the standard of duty and properly operation and maintenance of the dam and keep the safe condition in dam and around the dam and updating the emergency action plan. There are some common dam owner issues I'm talking, so mainly for in the government organization, in the public company, in charge or manager change or the transfer or retire. In a homeowner association, also in charge might change or the management might be changed. For the individual owner, the transfer of ownership and sell the property. So the new in charge or owner will be unaware of the dam safety laws and responsibility, and sometimes they did not inform who is the dam owner, new owner in charge to the dam safety, and it's very difficult to contact new owner. I'm talking the dam safety law. Where we find is the dam safety laws are found in the 5-501 through the 514 of the Annotated Code of Maryland environmental article, and the regulation of the Maryland dam safety can be found in the COMAR 26.17.04.05. And where we find the enforcement law. The enforcement law we can find in the Article 5-509B stated that on compliant or the department's own initiative, the department may investigate or examine any reservoir, dam or similar waterway construction. If the department determined that the water infrastructure asset or the dam is unsafe, need repair or should be removed, the department shall notify the dam owner to repair or remove the dam as the situation warrant within the prescribed time period. Some basic enforcement steps. The first one is the inspection finding report. This inspection will done by the dam safety staff periodically depending upon the hazard class. So in this report, they will ask for the certain action within the certain time frame and educate them why this is the important. The second is the 8, the strict inspection report. This is more legal language, set very specific actions and the time. One is notice of required action, very direct demand for the action, and clear that inaction will lead to the NOV. Then the formal notice of violation, and then lastly is the legal action if it is required. Sometimes when the department feel that when the dam is imminent danger of failing, department can skip the steps and can issue directly NOV to protect the public safety and welfare. So now I'm going to talking about some case of the enforcement issue in the 2020. The case one, the dam owner is St. Mary County, and this dam is located in the St. Mary County. This is 11 feet tall, 120 feet long, and 3.1 acre pond area and 3.3 square mile drainage area. And this is low hazard dam. So department received the information about the potential failure of dam. So the department conducted the inspection. After the inspection, the dam is unsafe and poor condition. These are some findings. I'm showing the photographs. This is the lake level at the time of the inspections. And there is a big sinkhole upstream side of the dam near to the spillway pipe. And there's the one of the spillway pipe is blocked completely. And there's a two wet area. It seems to be seepage in the downstream side of the dam. And there are numerous tree and woody vegetation on the upstream downstream slope of the dam. So the department issued the NOV under the 5-509B to lower the lake level and maintain the water level at a depth of no greater than 3 feet, and monitor the condition of dam and report weekly to the dam safety, and retain the service of the qualified professional engineer to permanently repair or to bridge the dam in a safe and environmentally sensitive manner. And these are the weekly report that the department is receiving about water surface elevations and the condition of the dam in the eroded area. And lake water level is lowered by using the siphon and existing spillway pipe. Case 2. This is the privately owned Autumn Dam. This is located in the Calvert County. It's about 20 feet tall, 300 feet long, and 6.8 acre pond area, and 0.5 square mile drainage area. And this is also low hazard dam. And then this dam is associated with the access road to the vineyard. About 100 vehicle passes during the event in the day. In 2019, dam safety inspected the dam and following findings were found. And there's numerous tree and vegetation upstream or downstream and seepage at the downstream, and the capacity of the principal and emergency spillway is inadequate. So department notified the dam owner with a strict inspection report within the prescribed time period. So removed all the tree and with the vegetation from the dam and established a healthy stand of grass in the place. And retained the service of qualified professional engineer to study for the spillway capacity, prepare the remedial design as necessary for the spillway, trash track, and seepage control. And removed filled on the emergency spillway channel to restore the emergency spillway capacity. Emergencies. On August 4, 2020, the department inspected the dam after receiving the information that dam was overtopping due to the rainfall runoff from the tropical storm ESS. So dam safety went to the inspection, and at the time of the inspection, the water level is almost the top of the dam. And there is the evidence of the overtopping of the dam in the downstream slope of the. And there is a huge sinkhole. There's the topple tree, head cutting, and significant erosion on the downstream slope. And there is a numerous tree and woody vegetation upstream and downstream to dam. So department issued a NOV under the Article 5-509B to maintain the water level 5 feet or greater below the normal pool elevation, and perform the emergency repair work to stabilize the head cut erosion area and remove all the tree from the upstream and downstream slope of the dam embankment, and retain the service of qualified professional engineer to perform the comprehensive investigation of the dam, including spillway capacity and seepage control, and apply all other necessary environmental construction and grading permit and complete the approval repair. So emergency work is performed and the lake is lowered by using this pump. And the sink, the erosion area filled with the gravel and all removed trees and woody vegetation and upstream downstream slope of the dam. Case 3, this is the private one Autumn Dam. There is a multiple property owner as you see in the photographs. This is located in Carroll County. This dam is almost 16 feet tall, 1,000 feet long, and 6.5 acre feet pond area. And this is located in U3 watershed. And this seems to be low hazard. And this dam is not in the dam safety inventory. The department received the information about the unauthorized work. So the department conducted the inspection. When during the inspection, the work is done by the unknown person or one of the dam owner, and dam found to be unsafe and poor condition after the inspection. And these are some findings during the dam. And the upper portion of riser toppled and spillway riser plugged with the mulch bag and the rocks. Inspection, the new outlet pipe is installed over the top of the existing pipe, and there is a lot of bare land as evidence. And there is numerous tree and vegetation all around the dam. So department issued a NOV under Article 5-509B. They removed the riser barrel blockage, mulch and rock, immediately stop any and all the work on the current dam repair or the construction, and stabilize any bare earth with the grass, seed and mulch, and monitor the condition of the dam and report weekly to the dam safety, and retain the service of qualified professional engineer to investigate the dam and determine the appropriate remedial measure for the repair work or to bridge the dam. And emergency repair work can be performed to speed up the process, and apply the joint federal state application to get the permit from the department, including final plan and supporting document. After 2-3 weeks, when the dam safety did the inspection second time, the funny thing is the riser structure completely blocked with the concrete, and existing pipe, outlet pipe is removed. And when we asked the dam owner, they said that they don't know who did it. And there's some issues. One of the owner is out of state, has been difficult to locate, and his business has been dissolved, and it's very difficult to conduct enforcement due to the multiple dam owner. The department has issued a follow-up letter to the dam owner with intent to bridge the dam in action on the part of the dam owner due to the unsafe of the dam. Thank you.
Here, that was a great presentation. Here is quickly becoming our enforcement expert. He's worked on numerous of these, and they've gone very well. Hira, your presentation was very clear, very good. We have no questions on it right now. So what I'd like to do is we've slipped about 5 or 10 minutes on some of the other presentations. So I'd just like to go ahead and take our break now for 5 minutes, and everybody can report back at 12:47. Thank you. Hi, Kelly. I can see your presentation. If you want to check your audio, that's fine too.
Yeah, I'm here. Do you hear me?
Yes, loud and clear. Thank you.
Okay, thanks. So, good afternoon. My name is Kelly Flint. I've been working in dam safety about 2.5 years, and today I'm going to touch briefly on potential hazards that you can find when performing a dam inspection. Dam safety's goal is just to maintain an awareness of safety issues that can be found at a dam at the forefront of the dam community. I'd like to start out by talking about who has the authority to ensure workplace safety. The Maryland Occupational Safety and Health Agency promulgates the laws, standards, and regulations regarding workplace safety. MOSH uses enforcement, training, and consultation strategies to strive to ensure that Maryland workplaces are safe. So please keep in mind that MOSH is available for consultation, outreach, and compliance assistance, as well as for general information, research, and statistics. So who is covered by MOSH? The MOSH Act covers Maryland employers in business, in trade, or in commercial or industrial activities who have one or more employees, and this includes state and local governments. So what rights do employees have under MOSH? MOSH lists 13 rights on their website under frequently asked questions. I'm just going to touch on a few, but foremost, if you believe there's an imminent danger situation at your work site, you have the right to request that the commissioner restrains that imminent danger situation at your work site. Secondly, you also have the right to file a complaint without the fear of termination or discrimination. You have a right to certain protective equipment under certain circumstances, and you also have the right to observe monitoring of toxic or harmful substances. So it's important for employers to know their responsibilities for their employees and for employees to know their rights in regards to workplace safety. So in my presentation, I'm just going to briefly go over a few hazards that can be found at a dam work site, and then I'm going to finish by talking about what a confined space is and how you determine whether a confined space requires a permit. So one hazard at dam sites are fall hazards. The photo on the left shows ladders being used during construction of a new principal spillway at an existing dam. And then the photo on the right shows an opening in the ground. This opening leads to the galley that runs through a dam. So outreach training for the construction industry is a training that's offered by the Occupational and Safety Health Administration. And this training covers how to use barriers at openings in the ground. And it also covers how to use ladders at a work site to prevent fall hazards. Then the weir wall is shown in the center photo. And so this weir wall
Kelly, is your mic on? I think some people have lost.
So Kelly, we can't hear you speaking. We can see your slides, but do not hear you.
Okay, thanks everybody for your patience with this technical difficulty. What I'd like to do is take a quick 5-minute break, see if we can get Kelly back, and if not, we'll go on to John.
There you go.
Kelly?
Can you hear me now? Sorry.
Yes, Kelly. Thank you.
So where did I lose everyone? I'm sorry. Where did I lose everyone?
Maybe go to this. We heard you at the beginning of the fall hazards.
Okay, so just start there. Here we go.
You were just starting to talk about weir walls.
Okay. Okay, so the photo in the center shows a weir wall, and this is considered a horizontal edge. And horizontal and vertical edges are considered are another type of fall hazard that you can find at dams. So the photo on the right shows the ladder entering into the galley, and the ladder is considered a vertical edge. So you want to keep in mind that any horizontal or vertical edge that's 6 feet above a lower level is considered a fall hazard. So you would need to use fall protection to access the edge. So fall protection can include guardrail systems, safety nets, or personal fall arrest systems. And fall protection is another type of training that's provided through OSHA. So the second hazard I'm going to talk about today is caught in or between hazard. A caught between hazard includes being squeezed, caught, crushed, pinched, or compressed between objects or parts of objects. It can also include being caught between a moving and stationary object or two moving objects. So the photo on the left shows a concrete section of pipe being installed. And so this is an example where the worker has the potential to be caught between a moving object and a stationary object. So outreach training for the construction industry is, as mentioned before, also includes training on how to keep yourself as safe as possible in this type of situation. So another example of a caught in between hazard is shown in the right picture. If an employee or a worker were standing between the excavator and the fill pile and the excavator turned, there's a potential for the worker to be caught between the moving object and the stationary object. So before entering a work site, you want to make sure that you assess the site and make sure that you're aware of any potential hazards on the site. And you also want to stay out of the swing radius of equipment. All right, so the final hazard I'm going to talk about is struck by hazards. So if you look at the photo on the left, it shows a crane moving a section of concrete pipe. And so here you would want to make sure that the equipment operator sees you. You also want to make sure that you stay out of the swing radius area of the moving object, and you don't want to be working under the load. And then a second type of struck by hazard is a rolling hazard. And so just keep in mind that dams that are roads, there's a potential to be struck by a rolling hazard. So you don't want to put yourself in front or behind of a vehicle that's moving forward or backwards. And you should also be wearing high visibility clothing with reflective material. So employees performing inspections of dams should take outreach training for the construction industry and fall protection training, which cover in greater depth the hazards touched on in the previous slides, as well as other potential hazards. Okay, next I'm going to talk about what a confined space is. So OSHA defines a confined space as being large enough and so configured that an employee can bodily enter it. It has limited or restricted means for entry and exit, and it is not designated for continuous employee occupancy. And Section 1926 .1201A specifically includes storm drain manholes and storm drains. And then furthermore, Maryland Code defines confined space as having limited openings for entry and exit, and as being subject to the accumulation of a combustible agent or an accumulation of a toxic agent, or it can have a deficiency of oxygen. And again, Maryland Code specifically in section 5-602 includes pipelines and tunnels. So consequently, tunnels running under dams can be confined spaces. So just to reiterate, storm drain manholes, pipes, and tunnels are confined spaces specifically listed in OSHA regulation or Maryland Code. So it's the responsibility of employers to ensure that a competent person identifies all confined spaces at the worksite workplace and identifies which confined spaces require a permit. So all dams, or a lot of dams in Maryland, have a riser structure and a principal spillway pipe. So are these principal spillway pipes a permit required confined space? So the first thing an employer should do is refer to OSHA's definition of a permit required confined space. So OSHA's definition says that a permit required confined space has the potential to contain a hazardous atmosphere. It can contain a material that has the potential to engulf an entrant. It has an internal configuration such that an entrant could be trapped or asphyxiated by inwardly converging walls or by a floor tapering to a smaller cross-section. And it can contain any other recognized serious safety or health hazard. So a principal spillway pipe has the potential to contain a hazardous atmosphere, and it also has the potential for stormwater to engulf an entrant in a storm drain. So based on these two potential hazards, a principal spillway pipe meets OSHA's definition of a permit required confined space. So what is OSHA's alternate procedure for entering a permit space? So the alternate procedure allows entrants to enter a permit required confined space when the only potential hazard posed in the permit space is an actual or potential hazardous atmosphere. But in order to do this, the employer must meet other requirements. And first of all, you have to eliminate or isolate any physical hazards. So in the case of the principal spillway pipe, the only physical hazard is the potential to be engulfed by stormwater. So in this case, the entrant, to the extent possible, should develop and maintain communication with the local weather bureau to eliminate the hazard. So once they've eliminated the engulfment hazard, it's met the first requirement for entering a permit required confined space under the alternative procedure. So there are additional requirements. The first one being the employer must also provide continuous forced air ventilation to maintain the safe space. And also the entrants must be able to exit the space safely if the forced air ventilation were to stop. And finally, the employer must develop monitoring and inspection data for the atmosphere, and they must provide the determination and the data to each entrant. So to summarize, a principal spillway pipe is a permit required confined space, but if it meets the requirements under section 1926.1203E, the entrants can enter under the alternative procedure. Right, so I just wanted to wrap up by with some final thoughts. It's important for employers and employees to be aware of potential hazards at dams under construction or during inspections. Employers should be aware of your responsibilities for your employees. Employees, you should know your rights. And you want to participate in necessary and required workplace safety training. And finally, please consult with MOSH and/or occupational safety and health experts within your organization. Thanks for your time and attention. Are there any questions?
Thank you, Kelly. That was very helpful. I'm seeing no questions that are relevant to safety issues at dams at this time. So we'll go ahead and take our 5-minute break now. And John Roach will be coming back at 1:07 with dam safety guidance documents. Thank you. John, I'm seeing that your desktop is live.
Thanks, Ray.
And your audio is clear.
All right, thanks everybody, and welcome back from our last break, or I guess we have one more break, and then we'll get into our Q&As. But what I want to do right now is talk a little bit about our technical memorandas that we've published and some of the hot topics that we're seeing in the dam safety program and what we're doing about it. And a lot of this hot topics you've heard about at least once today already. So let's get into it. We'll talk about the topics first, and then I want to briefly kind of go through the policy memoranda that are out there, that are under development, and that we see in the future, and then solicit your input as well. So among the hot topics we see are the thermal reviews for those small ponds or dams located in a Use 3 watershed. As you know, a Use 3 watershed is a protected watershed. It is a naturally cold water stream capable of supporting a trout population, and it's a prized resource in the state of Maryland. So although the regulations in COMAR stipulate that a dam safety permit is required for a pond in Use 3, there was a long-standing discretion, kind of a joint between MDE, DNR, and conservation districts, that under certain conditions, the local agencies were allowed to review and approve these ponds. And, as it goes, somebody posed a question as part of a project. It made its way to the Attorney General's office at MDE. And a little bit over a year ago, they advised us that COMAR is clear and explicit, and we cannot offer that discretion. So that has jumbled a bunch of lives and projects that were anticipating a SCD approval. People needed to be made aware that they had to seek a dam safety permit, and that added time and some expense potentially to their projects. So what I want to state, and I've already mentioned this a little bit, is that a regulation change is currently underway. The intent is to modify the requirement that the local jurisdictions, local soil conservation districts specifically, can approve ponds in Use 3. But we've got some work to do to get there. We need to make some agreements between the districts and MDE and issue some design best practices or clarifying documents for the thermal review and thermal considerations for design of ponds in these watersheds. So look for a change coming up. We hope this summer or later this year. But in the meantime, if you do have a project in a Use 3 watershed, it does need to come through dam safety for a permit. The county would still be responsible for any stormwater management or grading permits, erosion sediment control. The one thing to note is that if a pond is exempt from approval under Maryland Pond Code 378, for example, ponds under 4 feet embankment height, under 6 feet embankment plus 40,000 cubic feet of storage, or excavated ponds, it is our position that you don't need that dam safety review and permit because you would have been exempted from a 378 approval anyways. Next hot topic, of course we can't avoid it, is the impact of a changing climate. It's hard to deny it's changing. More intense storms, bigger temperature swings, prolonged drought periods. So we are looking at, are there any changes necessary in the design storms? We've mentioned today that we've got some grant money to explore updates to Atlas 14 in a state-specific probable maximum precipitation study. So those are in their fledgling stages right now. But there are bigger questions. Is, the 100-year, 24-hour design storm still always the appropriate design storm? Should there be a Ellicott City kind of replicate extreme short duration, extreme event analysis performed as well? So these are questions we're asking ourselves and chewing on. We love to hear input from folks. So if they have ideas, please reach out. But those climate change issues are something we are working on. Also, the maintenance and age of dams and the lack of maintenance is a perpetual problem. And it seems like during 2020, it became even more in the spotlight. You may know that the average age of a dam, inventory dam in Maryland, is over 50 years old. And while, you know, earth and concrete structures are generally robust, a lot of the components of dams are aging. And we've mentioned, you know, owners that change hands from maybe a farmer to a developer to an HOA. We're finding that the new owners have little idea of the required maintenance or obligations for their dam or small pond. And then that raises a bigger question. Who is responsible for inspections or enforcement of these structures? Is it a local agency or a state agency? So again, we're reminding folks that farm ponds are not exempt from maintenance activities, upkeep, the need for permitting or approval for repairs. And we really want to, you know, encourage and engender an all hands approach to the issue of aging infrastructure in the state. You know, partnerships between state and local agencies, engineers, the private community, all of the above is really what's needed to make sure we have dams maintained in an acceptable condition and removed if no longer needing value. You know, a 2019 ASDSO report stated that in the state of Maryland, they did this for every state, but they estimated for the state of Maryland has a $268 million backlog or bill to bring every dam in the state up to standards. That's a pretty amazing dollar amount, but we need to chip away at it one at a time. And lastly, we recognize, I think the whole community out there recognizes that Pond Code 378 is overdue for an update. It doesn't necessarily capture some of the stormwater management elements and features that we see today, and it just, you know, it lacks certain clarity in other issues. So it will require a heavy lift and careful thought to get Maryland 378 updated. We look forward to having some workshops and work groups in small settings to ensure that changes are technically adequate and make sense and are applicable up and down the spectrum of dams. This will probably end up being something that MDE quote owns as opposed to being an NRCS document. And it requires an update in regulations to refer to the new standard. So it's a process. We're working on it, and these guidance documents that I'm going to talk about shortly are kind of a stopgap measure while we work behind the scenes, kind of getting that framework of a new 378 out for some degree of comment and discussion. If you have any comments, suggestions, examples of better design criteria and things like that, please reach out to us. We'd love to hear and get your feedback. All right, so these guidance documents, a few of our presentations have talked about them. You know, let's touch back and say that the Dam Safety Division, as you kind of know it today, was formed in 1978, and our regulations have remained largely unchanged since then. And clearly things have changed in the world since 1978. So these dam safety policy memos that we've been putting out and working on, the idea is that they're not supposed to change criteria. We're looking to clarify acceptable design criteria, identify, again, like a roadmap, a path for permitting success, and they should apply to small ponds and dams. So we're just trying to, again, kind of course correct and fill in some of the gaps where 378 or regulations have ambiguity or need to be clarified. So I'm going to just go through them one by one and give you a very brief description of what they contain. And they're all on our website, available for download. So if you want to dive into them deeper, I highly recommend becoming familiar with them. The first policy memorandum we discussed expands and replaces a 1993 memo about plantings on roadway dams. The idea here is we want to, again, clarify the stance and clarify the expectations for what does a woody-free embankment and buffer zone mean. We'll define it through some diagrams and pictures and talk about steps necessary to remediate a dam if there is woody vegetation on it. Policy Memorandum 2, again, resolve some confusion in the existing Maryland 378, the special embankment criteria, it's been called, of when does a roadway culvert kind of exceed, you know, the straight face test on it being a culvert, and it's really acting as a dam. So this one actually has been revised multiple times as we look for clarifications and get feedback from stakeholders. And again, clarifying, adding more context, making sure definitions are consistent. These are the kind of things that we're putting in these memos. And so this is memo 2 in a nutshell is what it contains. Memorandum number 3 is, you know, an oddball, I would say. It's applicable when you have a dam or small pond at the crest of a steep slope. We had a few small pond reviews where we noticed that you know, the incredibly steep slopes, and from a geotechnical, geologic perspective, if you look at it, you're really relying on that steep natural slope to act as a dam or retain water. And the question is that adequate? Is that you know, geotechnically stable enough to not only hold the water back from an impervious standpoint, but also is it stable enough from a structural standpoint? Could it have a slope failure? So we've discussed the potential dangers of siting your structures too close to these steep slopes, and you know, some recommended setbacks or offsets that you could apply if you don't have more advanced geotechnical analyses to support the location being a safe one. In 2018, we released our draft hazard classification and dam breach guidance document, and that will probably be finalized in the coming year. But the policy memorandum number 4 was a tack-on that we added to that after it had already been put out there. And what we were seeing is that some extremely small, quote, you know, bathtub-sized stormwater management facilities. There was question on, you know, do we really need to go this far and do this much effort in a dam breach analysis? So what we decided was for certain, you know, really small height, small storage volume structures, there's a very, very simplified hazard classification. I think it's kind of a default hazard class A or low hazard for these structures. So that way it saves a little bit of time and effort in doing dam breach analyses for these obviously low hazard structures. All right, policy memorandum number 5, we're titled Best Practices for Construction of Dams and Small Ponds. This one has been under development for quite a while. We're coming up on 2 years now, to be honest, but it's one of those things where what we're trying to do is supplement the Pond Code 378 specifications, which, you know, lack detail and comprehensiveness to actually be a true specification to hand to a contractor. So this idea is we're developing this document to aid designers, contractors, and inspectors so that they all know their roles, the things to look for, the things to expect. You know, what's the expectations of quality of construction and construction inspection and QA/QC activities we would see for a dam or small pond. But again, there's a lot of stakeholders who have provided really valuable feedback, including the State Highway Administration, and we're kind of working hand in hand with them as they revise their standard specifications to incorporate some of these thoughts, and we're kind of working to sync up releasing both documents. That's why it's been lagging, but it'll be out there soon. All right, there's always been a big question about what to do when you want to remove a dam. It's not as simple as cutting a notch through the top of a dam. There's environmental and stakeholder concerns. You know, there's how do you design the breach adequately? It's an important process because some of these dams and ponds are really community assets, whether or not they're owned by the community. So a removal can be a challenging project just from a public relations standpoint. So we take some information from some best practices put together by others, also point you to some of those dam removal NGOs who have experience dealing and managing removals, point you to some of their guidance. And then we've had for ages unwritten basically criteria on how to design a breach adequately. And we're simply taking that unwritten guidance and writing it down. So now you know what we expect if we're reviewing a permit application to remove a dam. Going on with permits, we've had a permit condition for a long time that states that you need an impoundment filling plan when you first construct a dam. A dam that's newly constructed is probably at its most vulnerable state, statistically speaking, and more dam failures have happened on first filling than in prolonged service. And it's important to remember that first filling doesn't mean the first time you just put water into it. It's really, first filling can be thought of as the time it takes from when it first gets a drop of water till it actually meets its design storm, right? So you may have not actually stress tested your dam to its full design capabilities until you get that 100-year storm or even greater. So an impoundment filling plan, the idea behind this is because this is the critical time in the dam's lifespan, the impoundment filling plan describes the rate of filling, the conditions to look for, the frequency of monitoring to look for distress or other signs of problems at a dam. We've had this permit condition that one be filed with us before a dam is filled for a long time, and people ask, well, what do you want in that? What is an impoundment filling plan? So we've taken some guidance from the Army Corps of Engineers, distilled it, simplified a little bit, and put it into this policy memorandum so you understand what we're looking for when we ask for that. All right, policy memorandum number 8 is structural considerations for risers and trash racks. This is another one that's been under development for a while. We've received stakeholder input from various groups. And what we're trying to do here is clarify the design guidance where COMAR and 378 talk a little bit about structural design, but they don't really get you enough information to have a finished product. And oftentimes what people are doing is great and perfectly adequate, but there is questions that arise and there's inconsistencies. Or people ask, why are you asking for X? Because there's nothing that tells me that I have to do X. So we're just trying to put this document together. Another one that, you know, in this calendar year should be out on the street that describes our expectations for things to consider when you do these designs. And when I say consider, that's important because it may not apply. It may not be a strict, you shall do this, you shall do that, but have you, you know, it may spur the designer to ensure that they're on the right thinking train as you design it, because sometimes there's many ways to arrive at the solution that's technically adequate. All right, moving on to policy number 9. This is our water storage and collection tank policy. The definition of a dam in Maryland regulations and law is broad. I mean, you could be, you know, a little silly here and say that a glass of water could be interpreted to be a dam built for the purpose of storing or impounding water. So the question about underground or above ground or partially buried tanks has come up in the near recent past. If you're in the Baltimore metropolitan area, you've probably seen that the city is converting lots of its open water storage reservoirs to closed tank structures. And then, you know, there's also stormwater management where lots of projects are having underground chambers because of space constraints or site constraints. So what we're doing here is, you know, narrowing that broad definition of dams for when is a large water tank something that may need to be considered by dam safety. And we're really looking at this from a public safety perspective. Concrete tanks are generally robust, but they are not exempt from failure. It could happen. So we're looking at the storage volume and the size of tanks and the downstream exposures and deciding on if they will be, we should be looking at them for dam safety review or not. All right, number 10, utilities and dam embankments. I think we all know that a utility that is within a dam embankment is a potential weak spot. It's a potential weak spot because whether it's carrying some kind of fluid, it's an air, a water, a sewer, or it's got hazardous material in it, it has the potential for breakage and damage to the dam. It's also got the potential where a utility contractor may not realize that they're digging in a dam embankment when they place these utilities, and they could be doing damage to the embankment that they don't even realize if they're, let's say, digging up and replacing a water main. So it's policy memorandum number 10. Again, make sure that we're all aware that utilities within dam embankments and near dam embankments need special treatment and what that special treatment might be. Policy memorandum number 11, I talked about it earlier today. It's our activities, clarification of activities that we consider routine maintenance that do not require a permit or authorization. And then lastly, I've mentioned 3 now. This is the 3rd of policies that are under development, but they're very close, I think, to the finish line. That was policy 5, 8, and now 12, which deals with excavated ponds. You might be saying, well, 378 already has an excavated pond section, right? But there's some contradictory language in 378. You know, it says if an excavated pond has a spillway that could fail, it needs to be treated as an embankment pond. And that opens up a whole other can of worms of questions. When the NRCS originally developed, 378 or predecessors, the excavated pond was really truly excavated, a hole in the ground dug out by typically a farmer for livestock watering and things like that. And as we've evolved and incorporated more stormwater management practices, what constitutes an excavated pond has changed. And now we've got what we call them closed storm drain system ponds. That's our, for lack of a better terminology we use internally is, you've got what's a largely excavated structure, no embankment, but it's got a spillway because it basically discharges into a large storm drain network. How do we handle those? So we're just trying to bring 378 in line with the times, reduce some of the ambiguity that's in there, and that's something we look to get out. Again, this calendar year, hopefully the sooner the better. So that's what's out there and coming soon, but there's more. There's always more, right? We'd like to work on a project review guide, which there's some states, Colorado, Montana, and a few others have some really great examples of, it's a very clear and explicit roadmap of what we're looking to review. So we provide that to the community so that they know what to submit so we can review it in a timely manner. That's something that will take more effort and something we'd like to work on. We've also got in the works some guidance on what dam safety is going to look for these smart ponds. Hal called them the CMAC, the Continuous Monitoring and Adaptive Control. The idea here is that you've got, a cloud-based computing solution that looks at weather forecast and actual rain data and can adjust slow flow orifices to better manage stormwater for quality and potentially quantity as well. So retrofitting a device like that onto a dam or small pond is something that needs to be reviewed and approved because it is a change and it may alter the spillway characteristics. So we're putting out some guidance on not the stormwater side of it per se from like a crediting or volume standpoint, but what should be reviewed from a dam safety standpoint. We see a need to develop some weir wall design guidance, some structural guidance. 378 refers to an outdated document that's actually been rescinded. There's still some very good data in there and information, but I think we probably need to provide something new to the community because there are some persistent problems or design issues that we see and comment on often. We also have some geotechnical investigation guidance and design guidance that we look to put out to supplement regulations and 378. I'll be talking tomorrow about some considerations for investigations, excuse me, and hopefully converting that presentation into some guidance document We like to put some filter diaphragm design aids out for people. Some considerations for dam siting, right? So that we are aware of setbacks required to adequately maintain a structure, to have adequate access to it for maintenance or emergency needs. You know, ways to avoid having multiple property owners. Well, it's not that you can't have multiple property owners, it's just that it gets much more complicated when you have people with little slices and sections of a dam, and they're all collectively responsible for it. And then possibly last, Visti mentioned some risk-based and risk-informed decision-making processes in his Hhpd presentation. You know, we've got some great feedback from our friends at U.S. Fish and Wildlife Service who have some screening level risk analysis. This is kind of a real qualitative dive into your dam and understanding risk drivers and factors for potential failure modes. We think a better understanding of risk as it pertains to dams can help owners understand their assets and have an asset management strategy, but can also help inform the state of what's out there. So, you know, this is like at this point we're maybe getting a few years down the line here, but putting out some kind of guidance for that as well. And there's going to be more things that come up as questions get asked, and we say this is something we can easily answer in a guidance document and put it out there as we're developing regulatory changes and design guidance changes. That being said, we want to know what you need. We really want this to be a collaborative process to the extent possible. And if you have questions that are perpetually coming up that you don't know the answers to, you need guidance for X and Y and Z, please reach out. We, you know, we've probably been seeing some of the same questions and issues and thinking about how do we tackle that. So let's work together so that our broader dam safety community benefits. So that's the end of this presentation, the end of the technical sessions for today. I'm happy to answer any questions if there are, and then we'll pass it off to Ray for a wrap up, and we'll try to get through any of those other questions we didn't get a chance to answer in our previous sessions.
Great, John. Thank you. And thank you for everybody for hanging in there. It's been a long day, but it's been a great day. Lots of good information. John, thanks for your leadership in getting out all the technical guidance bullet documents. It's very helpful to this community. What I'd like to do is take a 3-minute break since we're getting good at this, or maybe a 2-minute, and meet back at 1:37. We've got a top 10 list of your questions prioritized for answers. So that's your teaser to bring you back at 1:37. Thank you. Jennifer, can you see my desktop presentation?
Yes, I can.
Thank you. Okay, it's 1:37, so I'm going to go ahead and get started. I'm Ray Barr with the Sediment, Stormwater, and Dam Safety Program And what we've done is we've been capturing all of your questions in the chat, in the question and answers. We got a lot of great ones here. I don't know that we're going to be able to get to all of them, but one thing we will promise you is we'll do a frequently asked questions guidance document, and we'll put all of our answers in there and send it out to everybody who's registered for these sessions. I'm going to go ahead and jump in. And the first question that we have, and I'm going to try to direct it to the person who I think is most appropriate to answer it, but anybody from the technical staff, if you've got the answer, please jump in. The first one is going to be for Jennifer. When farm ponds are handed over to an HOA, do they need to be retrofitted to current regulations?
Actually, I'm going to defer that to John Roach.
Can I defer? No, just kidding. You know, at the end of the day, a dam owner is always responsible for ensuring that their dam meets the regulations. So I would strongly hope that a developer doesn't hand over a broken dam to an HOA, but I think the position I would take is yes, particularly if it's not a farm pond anymore, whether it's a recreational feature or stormwater management, it does need to be upgraded to meet the current regulations. The grandfathering, there's nothing that's necessarily that I'm aware of in our regulations that allows for a degree of grandfathering. So to avoid any questions or whatnot, I would suggest, yes, you should retrofit it and ensure it meets the current design standards, whatever they may be.
Great. The second question is going to be for Hal. Hopefully I'm directing them correctly. Hal, I think you got this one in your back pocket. Is there a consequence for a pond owner who cannot afford to bring their dam pond up to NRCS 378 spec? Instead, they hire a contractor to band-aid the problem with no professional engineering assistance.
Good question. Thanks, Ray. Yes, there is a consequence that any person who works on a pond or dam without a permit is violating the law and regulations, and we can take enforcement action if we find out about it. And you need to, the owner will be required to bring their pond up to standard or remove it. That's what's in our law.
It's also important, if I could jump in, to say that, you know, there's a liability, owners have a liability attached to their dam and pond. So if you do band-aid fixes and something goes wrong and fails and hurts property or kills somebody, you know, that's even more, that's going to be found in legal discovery, and you're going to be sued, and it's going to look very bad and not be favorable to your cause if you're found to have done unpermitted modifications that may have contributed to that failure.
Also, I'd just like to say more and more, we're considering the environmental damage downstream of these dams, especially in the Use 3 waters. So any debris or heated water that would be discharged that would ruin downstream habitat, the owner of the dam would be liable for as well. Hey, Hal, since we got you here for a couple more weeks, we're going to pile on the questions here. So the next one's for you as well. Who owns a dam if more than one property line is on the dam?
Good question. All the parcels that comprise the land on which the dam is constructed are considered owners under Maryland law. And to further expand on that, our law right now under 5-509 says that owners of the reservoir, say a homeowners association is formed and there's a dozen people that have property that includes part of the lake, they are all liable for operation and repair of their dam. And if there's an association that operates the dam but doesn't own it, I think operators are also liable, but that requires some legal investigation. Right now it's the owners. So if the dam sits on parcels two different parcels, both owners are liable.
Okay, we've got a second part to that question, Hal.
Okay.
Are there any regulations or laws that prevent farm ponds from being divided among numerous owners?
There are not.
Could I expand on that, Hal, and say that there are not any laws associated with dam safety, but there may be local regulations or other land use laws that might be needed to be considered.
Sure.
Okay, priority question number 4. This one's going to go out to either John or Jennifer. If the existing dam is downstream of proposed development, who is responsible for maintaining it?
Well, I can start with the answer to that question being the property owner or the owner of the property that the dam resides on. But Don, if you have anything to add.
I don't have anything to add to that. You know, if you're directing stormwater, let's say, flow from your property onto somebody else's, you know, you can't just put more water onto somebody's property by right. So, you know, there is I'm not a lawyer here, so I could say there's probably a case to be made legally that if you're putting more water without appropriate approvals, that causes a dam to have problems, then you probably have some responsibility for that. But, you know, if all the permitting is done properly, it pretty much lies solely with the dam owner.
Okay, great. This one's going to be for Scott, and Scott will be presenting on Thursday for us. So if you're there, Scott, it's here we go. Is there a resource for dam owners to go to in order to determine their hazard classification?
Yes, we have a guidance document available on our website. You can access that by going to, let's see. Well, the Google shortcut is MDE Dam Safety Technical References, and within the technical references, there's a dam breach guidance document and associated spreadsheets that will help you determine the hazard classification of your dam. But I recommend hiring a qualified engineer experienced in performing these studies. But you're certainly welcome to contact anyone at the Dam Safety Division, including myself, and we should be able to help you in that task.
Okay, great. Thanks, Scott.
I'd like to add to that for a second. One thing to keep in mind is that there may have been a breach analysis and hazard classification done for a structure 20 years ago. That may no longer be relevant because of what we call hazard creep. So if a subdivision has been constructed downstream of a farm pond, that farm pond may no longer be low hazard, and it needs to be evaluated under current criteria and ultimate development of the watershed.
Great. Thanks, Hal. Thanks, Scott. This one comes in from our own Amanda Malcolm in our Plan Review Division, and I'm going to direct this one to Jennifer. Who at MDE reviews in-stream small ponds that are located in a regulated stream but not use 3?
So the short answer to that question for small ponds that are not in a use 3 watershed that are where the applicants are state or federal applicants, that those small ponds would be reviewed by MDE, by our program, and currently that work is being done in our Plan Review Division. Somebody else might want to weigh in on the answer to that question when it's not state or federal applicants. John or Hal?
If it's a small pond, but not in use 3, then that would, you know, if it qualifies to be a small pond, it would be reviewed and approved at the local soil conservation district level. You would probably, in addition, need a wetlands and waterways permit for the in-stream work and potentially Army Corps approval. But if it's really a small pond, then dam safety probably wouldn't be involved in the permitting of the structure itself.
I'd like to add a little something to that too. If it's in stream, you don't see many of those kind of dams being constructed anymore. And if it is a dam, it would probably come to dam safety, and we probably put it out on public notice. And I imagine there would be quite a few comments that we would receive from various agencies, and we're liable to hit upon somebody that does have an interest in it legally.
Okay, thank you, Charlie. Hal, got another technical question for you. Can you please provide additional clarification on how the upstream toe of dam elevation is determined? For example, proposed grade versus existing grade prior to the proposed dam construction.
Sure. I think it's in regulation COMAR. It's above the original stream channel. So if there is 20 feet of fill put in on a site and then you put a pond on top of the fill, a strict interpretation of COMAR means you're going to have a very tall embankment because it's from the original stream channel. If there was no stream channel, it would be from the original native ground. And it does not include the cutoff trench, but the upstream toe criteria was selected in our law because that represents the depth of impounded water. So it's a little bit at odds if you have a 6-foot deep stormwater pond on top of a big fill area for an industrial park, but technically the height is measured to the original stream channel.
Great, thanks, Hal. And John, I'm gonna toss this next question to you because you've got it in your queue for upcoming technical bulletins from Maryland's Dam Safety Program. The question is, we are interested in doing remote telemetry monitoring in Howard County for our higher hazard dams with EAPs. Is CMAQ the way to go for water level monitoring?
I think, well, without being a salesperson for these products, because they're all proprietary, I think CMAQ is more than you need to buy. The idea behind CMAQ is that not only does it have that real-time water level monitoring capability, but it also uses National Weather Service predicted rainfall amounts and rain gauges within a watershed, and some AI and big computing data to predict inflows and adjust low flow orifices accordingly for stormwater management. I will note that at the moment we are not inclined to permit them on higher significant hazard structures. So I think if you're purely looking for water level in the reservoir, there are many, many vendors who can provide that to you with an integrated solution that can have that, with uplink to a website that's all secure. You can also add in other instrumentation like piezometers within your dam, or even flow gauges if you have a seepage flume or a discharge point you want to measure. So there's a lot of product vendors out there that can provide you with real-time water level monitoring. I think, again, CMAQ can do it, but you're buying into a much bigger system that it sounds like you're not asking for, so may not be your best use of money.
Okay, great. Thanks, John. And one more question for Hal before we conclude the meeting and some closing remarks. So Hal, do state regulated dams require owners to engage an engineer for inspections? I was under the impression they could be conducted by the owners themselves, apart from those inspections conducted by MDE.
Good question. John, you want to jump in?
I don't think there's anything that explicitly says you must have an engineer do your inspections, periodic inspections. COMAR does explicitly say that an owner is responsible for inspections, I believe, annually and after large storm events. So Whether the owner wants to delegate that responsibility to an engineer is maybe on their end.
Yeah,
It
thanks.
probably ties into your level of sophistication and the complexity of your dam too, right? Like, you know, a lot of people can do home improvement jobs or car repairs to an extent, but you may be fixing or looking at a symptom and not addressing the cause. So it does help to have trained eyes, you know, on your dam or your house or whatnot, to really look into, make sure that you're catching all of those things that you might not be. So maybe not every year, but you know, again, we do think a periodic top to bottom review is a really good way to plan for budgeting for future work on your dam, to have a good understanding of your asset, and, you know, potentially even reduce your risk of ownership. So I'll leave it at that.
Yeah, thanks, John. Really good information. So again, we're going to wrap up all these questions into a FAQ and get it out to all the registrants. I'd just like to provide some final notes here. There were numerous questions. If the presentations were going to be put up, yes, and we hope to get a video up as well. PDF certifications, we cannot give them, but we will send out a certificate of attendance that you can do a self-certify for PDH credits through DLLR. So how are we doing? You know, ASCE gave a report card of Maryland's infrastructure in 2020, and Maryland Dam infrastructure rated a C-, and this is down from a C back in 2011. Dams are often the overlooked infrastructure when you're comparing us to bridges and aviation and drinking water and solid waste. So it's critical for us to make the public aware of dams and the safety issues around them. And as the dam owners, you are important in helping us to get the message out. Fortunately, we have, here, again, just to follow up, how do we raise our grade? As a community of dam owners in the state of Maryland, how do we raise our grade from that C-? And it's finding those funding sources from state and federal programs. We talked about that today. We're all in with you trying to get some of these federal grants. We also have our Water Quality Finance Administration for low interest loans. Provide greater resources for MDE to educate dam owners about performing the necessary dam operations and maintenance activities. I think that's what we're doing today and Thursday, and we hope to continue these dam workshops on an annual basis. Here's a good one: increase the amount of public education to dam owners to increase the number of updated and exercised EAPs and promote more frequent inspections and maintenance of high and significant hazard dams. Fortunately, we got some events coming up in April. Look for an announcement in early April from Governor Hogan. The Sediment, Stormwater, and Dam Safety Program is going to have a week where we're going to put out blasts, tweets, and Twitters on flooding and dam safety and stormwater management. Also, the hurricane season is coming. It begins on June 1st, so it's a really good time to go out and do an inspection of your dam. Also on May 31st is the National Dam Safety Awareness Day. This is when we join together state, local, federal agencies to encourage investment in America's critical infrastructure. I do want to just talk about the emergency action plans here really quickly. They're required to be exercised once every 5 years. That's in COMAR and or the recent law that we passed, and that deadline is coming up. It will be spring of 2022. Unfortunately, right now, only 35% of our high and significant dams have done an exercise of their emergency action plans. If there are counties that would like to group a bunch of their high and significant hazard dams and put together an emergency action plan exercise, the department would be more than willing to jump in and help you with that. We've done that successfully in numerous counties, Howard County and down in Culver County. Also, the National Weather Service has updated contacts for us. So everybody, when you update your EAP, which the updated EAPs are due on May 1, please update that information. Right now in the state, our high and significant hazard dams, about 80% of them have an approved EAP. We would like to get that much closer to 100. As you know, as we've talked about today, we have many different ways in which we get information out to you through our technical bulletins. We're going to be working on the regulations, as you know, working on getting grants for the dams. So please make your the dam safety programs one of your favorites and check with us often. If you'd like to join us, we've got 2 or 3 opportunities. One that's closing this Friday on March 19th at 5 p.m. If you're a dam engineer and would like to work for the state of Maryland, we would love to have your help and assistance to help us improve our programs. And with that, I'd just like to give you a little bit of a foresight into the agenda on Thursday. With that, I just want to thank everybody. It's been a very long day. We still have 250 people. It's been toggling back and forth between 270 and 280 people every day. I think this is the most people we've ever had at a dam safety workshop. And we're all in this together. And I just really want to thank you all for attending, and let's get the word out, and let's improve our grade from a C- in the next ASCE evaluation of Maryland's dams. Thank you. Are there any final words from anybody else from Maryland's Dam Safety Program?
Thanks, everybody. It's been fun working with you.
See you all March 18th.